And let's get things underway. Let me bring this up and we'll talk about first of all, is everybody able to get the materials downloaded and everything successfully? Everybody good?
Yeah, I have them.
Yep.
Okay, good. And so what we want to talk about now is sort of real quickly, I'll talk about the nature of the manual of the training manual itself. And you can see, of course, it's got a table of contents, obviously. And these items in the table of contents are hyperlinked. So if you are looking at it in the PDF on your screen, you can say maybe if you want to look at this exercise here, putting it all together, you can click to it and it'll take you straight to it. So that's there, but we've got a little bit of upfront uh, information on how Carlson stores their files, what the command structure breaks down into, what various menus, various modules, and then then settings, whereas settings only has like a single page in the manual. However, it's something we'll spend a little bit of time on because there are some settings that are important to know about and to know where they are and how to set those because they govern the behavior of the software and sometimes in radical ways. So if you're not aware of those, it can be a problem. So we'll spend a little time on that this morning. And then these the rest of these are like some discussion. You see these important concepts, and then talk about Carlson points, and then a little exercise about points, and then point groups, a little exercise about these. Now, all of this stuff, all the way down through this second page of the contents here, where you got 1, 2, 3, 4, 5 different exercises of putting it all together workflow. That's all basically the fundamental aspect of the software. In fact, this is the exact same content that you get in the fundamentals class, but we just get 2 days to go over it a little more leisurely and a little more in depth. So if we maybe skip past some of these, you can always go back to these and refer back to those. And all of the data files that you need are in your data set. And so that would be to at that page. And then the rest of these from the next point down is talking about the civil module specifically. And we've got, roadway design, some grading tools, pads, cuts and fills, other site elements, road network. And then we have these command references for these general menus, the file through points, and then the civil module menus. And that's the rest of the menus in the civil module. And this is, for instance, if we look at, I'll just go to the edit menu for an example. Um, and this is the command reference section, the part after all of our um, examples and exercises. And this is basically a little synopsis of all of the menu commands in the system. And you can see a couple of things here to take note of. One of which is that uh, these commands listed here that you see in the book, some of them you see I've got highlighted in red and others are not. And all in the world that means is that over the years and using the software, for a couple of decades now, you know, I've come to recognize some commands as being really useful and really helpful and good to know and be familiar with. And those are the ones that I've sort of highlighted and read there. Now, that's not to say that everybody's going to find that same cause. You see, some of these are not exactly the same. Like here's one, edit polyline vertex. And now we do it. In fact, it says right here, it's largely replicated now with polyline grip editing, but that has some, there's some additional controls in it. There's some things about it, and you can see a little, if you do a vertex edit with Carlson, you get this dialog box up where you can control things like the, incoming slopes, outgoing slopes, elevations, individual things like that that you can't really do with just simple grip edits. But it's not one I use a whole lot of because a lot of these things you can do, using the standard CAD properties as well. You can step through the vertex locations and change their elevations, etc. So when you see those, bold faced red ones, those are ones that sort of take a little special note of. The other thing to note is that you won't see all of the commands here. If you see, here's the pull down from the edit menu. There's undo, redo. The clipboard has some, then erase has a pull right, erase select, single last. Then we get into the Carlson commands, erase by layer, close polyline, erase outside, and a temporary erase. Now, notice the first one you see in your book here is the erase by layer. And that's because if, these, um, what the book commands are going to have is a little synopsis of all of these Carlson enhanced variations of standard functions. So if it is a standard CAD function, you're not going to see it over here in the menus, but you will see all of the Carlson specific commands. Now, um, some of those, if I look back on, this is the file menu. Let's see, starting here. So there's new, open, close, project, draw and explore, save and save as. Now these are standard CAD commands like new, open, close, save and save as. Um, but within all of these different ones, there are typical additional Carlson, um, variations and enhancements on standard commands. So those are the ones you'll see in the command reference. Okay. So that's just as a little thumbnail of the way the manual is put together. Now, here's a bit about uh, my background here. I'm not actually this number here is actually now over 40 years, but um, in any case, the real thing that I want you to take away, two things here. I want you to take away two ideas here. One of them is that, I'm actually still a practicing engineer. I have my own practice. Um, and this is part of what I do for that practice is I'm a training specialist for Carlson and for some other software as well. Some of the Bentley, Open Roads. Used to do Civil 3D training, but I sort of dropped that. It's sort of hard, it was Autodesk was basically requiring us to, um, have certain quotas and so many training classes all the time, and I didn't have the bandwidth to do the training and to do the consulting and the engineering work all at the same time. So um, anyway, the bottom line of that is that I've got experience in the field into what we're doing. I'm not just simply a programmer or a salesman that knows how to demo the software. So if any time that you have any issues with any of these concepts or commands and things, always reach out to me, get back to me, and I can, I've done that same type of work, so you know, I'm, I've got time in that particular battlefield, and that's the other thing I want you to take away from that is that you have my email address down there at the bottom where you can get in touch with me, and that's for anything that you want or need in terms of support. It doesn't have to be something we talked about in class. You can, Should be something Carlson related, of course, but so, you've got access to us as a technical support resource. Um, it can even extend to the point, if it gets into, and by the way, that support is not ever charged, just answer a quick question or demonstrate a quick concept or something. We can do that at any time. But I've had several clients now, I'm going to say maybe four or five over, oh, maybe the last 10 years or so. But sometimes they'll get in a situation where they get really tied up and busy on a project and they need help. They haven't really gotten up to speed with things yet. And so they will actually hire us for me to come in and work as basically either as a sub-consultant or even work like an employee of that company. So, they can build into their particular project budget, funding to take care of that. And we do that on an individual basis. So if it's more than just a single, a simple question or concept, if it's something that you need help over a period of weeks or maybe or months perhaps, and you need some assistance with that, or just need extra manpower, we can talk about that as well. So, but the key thing there is to stay in touch. You've got my email. Um, I've done this kind of thing before, so um, should be able to help you out here. All right. Now the other thing to take note of. Let's see, here's a couple of little icons here that you're going to see. Something that might be a nice little concept. There's a tip or a trick, a good idea. And then here's something else that's important to take note of. So you'll see a little notepad. These other ones are, if it's an IntelliCAD version feature or an AutoCAD only version feature, you'll see that. Now, there's no command in the software that requires either one of those packages. It's just sometimes it's slightly different in the way it's presented. So um, you'll see a little note, those little icons on the side. All right. So now I'm not going to sit here and read you this stuff, but this is really this little business here is basically talking about how Carlson works and how it does its design and calculations and all of that stuff. It uses a CAD engine. So it's using AutoCAD or IntelliCAD to accomplish what it's trying to do. And really, at the end of the day, what you are left with after doing your work is still just a CAD drawing. It's not a special proprietary formatted file. It's not anything like, you know, trying to think, William, something you might be familiar with, like maybe, is it Minsoft or Mindsoft? I don't know. Um, there's a couple of really expensive, high-powered mining modeling packages out there, and the data files that they wind up using are very specific to that program. But in this case, Carlson is running just on a stock CAD platform. The difference is Carlson has basically taken the role of translator, if you will, between the user and the AutoCAD system. And you want me to say AutoCAD, by the way, and I mean that interchangeably with IntelliCAD. So in fact, I'll probably be using the IntelliCAD version to do the training with, um, unless there's something specific. I've got them both, but we can see. Um, and so Carlson, the software itself is working sort of like a translator. Like you might want to design a road profile with parabolic vertical curves. Well, AutoCAD doesn't know the first thing about doing that. It knows about, putting the pen down and drawing on the screen and then picking the pen up, and there you're left with a what looks like a parabolic curve with some graph lines on it. So, but the AutoCAD side of the picture doesn't care one whit whether you're designing roadways or whether you're drawing dress patterns or floor plans or circuit boards. It's just a drawing package. So Carlson's going to sit on top of that, and it's going to um, gather information from the user, from us as users, and we answer questions, usually in the form of a pretty extensive dialog box, and that gets everything all set to be able to hand it off to AutoCAD in the background. Then AutoCAD goes to work on it in the terms it understands, does what it needs to do to produce the items or calculate on the items or whatever. And then it sends the results back to Carlson, and then Carlson reports it back to us in terms we can understand. So it might, label the start of a curve as a PC, as a point of curve. Whereas, AutoCAD doesn't know to call anything a PC or a QRS. It's completely agnostic of that. So um, that's really what's going on here is that Carlson is that interface between us as users and between the CAD system as just a dumb drawing system. Okay. So when we look at how things are organized, we'll explore it a little bit in the system. Is that we have this CAD system in front of us. It has a drawing area where our graphics are displayed, and there's all kinds of tools that give us those uh, drawing items or let us ask questions about them. And you'll see in a series like in this screenshot here, you see a bunch of different icons for different commands. There's also pull down menus from this top row here. You can see they all start with file, edit, view, draw, inquiry, settings, and points. Those are our general menus. And then within those, you have a number of menus and pull right menus. These side menus or sub menus. So that'll work. You also have a ribbon interface. Now you can use the ribbon interface and totally do without the menus if you'd like. I personally don't use the ribbon interface because you can see how much vertical uh, height, because the tabs all have a label that sits up above the ribbon, which is 3 lines thick, and then a title under that. And so it takes up quite a bit of valuable screen real estate, in my opinion. And so I never really learned to use it that much with this particular software. Unlike, I mean, I know ribbon interfaces like with Microsoft Word and such like that. There's really no way around it. But anyway, I'll show you how you can turn those on and off, and you're certainly welcome to use them, but we'll be sticking with the menus just so you know exactly where they are. And I'll show you ways to find commands that you might not know where they are as well. Um, but there's a nice little tool that Carlson has built in that can help us find those commands. All right. So we'll look at that and see how that's organized. And then it's, we need to understand a little bit about where information is stored. Now, out of the box, the default condition is, you can see right here that Carlson comes pre-configured to put all of the project data files into folders on the computer. And by default, they're set to the drawing folder configuration, which simply means wherever you say that when you first start things up and you save the drawing, or you give it a name and tell it where it's going to go, then by default, all of the dependent data files, things like surface files, coordinate files, center lines, profiles, all of that civil type data gets stored in external files. It's not stored inside the DWG file like Civil 3D does. But it's stored externally, and those files in this default condition, this drawing folder configuration, it's what we call follow the drawing basically, and it's going to by default look in that location first for those files. Now you always have the ability to browse away from these default locations and choose another location when you're doing your work. You're not forced to have them in any given folder. You can, even in the middle of a particular single editing session with a single drawing file, you can put, center lines in one folder and then change locations and put them in another folder, So nothing is ever set in stone. These are just default locations. There is a total of 3 different options here. Let me see. I just forgot about doing this. There we go. Now you can see my pointer a little better. I always forget about turning that on. So, but these 3 options you can see right here. There's a project folder, a drawing folder, and a fixed folder options. Again, the default is the middle one, that drawing folder. The fixed folder means that you just have a particular folder location on your computer or on the network, and that's where everything is going to go by default. Regardless of which project you're working on, which data, which drawing file, any of that, they're all going to go in that one location. Now, that used to be the way Carlson worked way back in the early days of the software, back in the 1980s. But it's a bit outdated, but it's still there if you want to do it. The other, a bit more sophisticated version is this project folder method. And what that does is allows you to make a list of, and then you can see right here on this this little example here, wherever you have a project. Okay, and so you will declare a project, and it goes out and it either finds a folder already of that name or it makes it for you. And then what that project name, underneath that project name, you would pre-build this list of folders. And you can see here, and this is just an example. I've got one for alignments and profiles, one for drawing files. I've got one for other, and then inside of it, there are other folders like deliverables and PDFs, and you get the idea. So you can break that down any way you want to store it. And that's where all of those data files then are going to go by default when it goes to look for them. So you don't have to keep navigating your way around. It will take care of jumping over to those locations. All right. Now there's one particular thing that we can do with this particular this project folder idea. So you can set up the project folder subfolders. That's this here. And then this other one says these data type subfolders. That means you're going to assign the different data types into different folders. And here's an example of what that looks like. So you can see down here, number 8, this .cl, that's a centerline file, and I'm going to have it go in wherever my project is. It's going to have a subfolder called data and one under data called alignments and profiles. That's where it's going to go. My CRD or coordinate files are going to go in project data points. Some of these are not defined. You don't have to define them all. In fact, there's like 270 some or 90s, 290 some. I forget the number. Um, but you can assign those, as you need. And if you don't assign them, they're going to just go by default to wherever that parent level folder is for your particular project. Now, all of that being said, this is the typical real world way that this generally works, that this project folder method is really best suited for larger organizations with multiple employees perhaps working on projects, at a given times, and maybe even with multiple offices in different locations, so that any given one can, get up from one computer in one city and, you know, drive to the other office and sit down at another computer, and they know where all of this stuff is going to live, and it's all consistent across the board. So that's a nicely, organized means of managing your data. The um, the real or the I guess the bigger reality of it all, and that largely stems from the fact that it's preset this way by default, is that we almost always will, particularly if we're a small organization or even a lone operator, we're going to almost always work with the drawing folder method. And that way, all the data files that we're working with, we can count on them being there in that one folder location. Okay, so it does put more files in that particular one folder, but you know where they are without having to track them down. So that's just a little bit of that organization. Um, then we talk about what's on these different menus, and there's a split in the menus. Let me see if I can see a picture. I don't. Well, maybe this one will show it. Yeah, you can see here all of the Carlson modules, whether you're running civil or you're running survey or you're running surface mining or underground mining or geotech or GIS or hydro, they all start with the first 7 menus of file, edit, view, draw, inquiry, settings, and points. That's fundamental to everything in the software. Everything after that then is specific to the particular module that you are in. The picture you see on the screen here tells me that I'm in the surveying module because I see that survey, COGO, centerline menu set. Now, the next, like in civil, you don't have a civil menu. The one there is called 3D data. Okay, so it's not going to tell you the name of it, although it will tell you up here in the top of the screen, it will tell you which module you're in. This is Carlson Survey. If you're in civil, it'll say Carlson Civil. So you'll see that, and you'll know, which one you're in. So all of those file through points, those are the fundamental ones, and then um, all of the ones after that are specific to the module. Now, they happen to be, in general, uh, split along those lines in terms of functionality as well. The things in the fundamental sides tend to be, sometimes they're just standard CAD functions. Sometimes they're just very, you know, early getting started type of functions, but some very, very important commands like, the draw commands, etc. Once you get into the specific module menus, it's where you're going to get more of the deeper dive, the bigger dialog boxes, and you're really going to be coming up with some, more of the in-depth type of commands. And that's just a general rule of thumb because there's plenty of work you can do in these upfront menus as well. Okay. So with that, and I'll let you read all that kind of stuff, at your leisure. There's nothing really more going on there. So we need to talk about some settings and what they're going to do. And again, we've got this one page in the book that talks about settings, but here's what we are going to spend a little time on right now are these settings here so we know how the software is going to behave. And also remember this, there's a little light bulb icon for you, but in almost every case when there's a dialog, if you're asked to fill out a dialog box with different settings that control the results of a command or a process, then you're able to save those and recall them later. And you'll always see and always look for these load and save as buttons at the bottom of any kind of a dialog box because, and here you can see even with this one, there's load and save, and this is the settings manager or settings explorer rather. So that's a real big time saver. Excuse me, if you find yourself changing, like let's say you're going to, let's do a simple thing. We're going to draw contours from a surface file. And if, if you're going to draw, say, existing contours, you're going to want them to have a dashed line pattern. And, excuse me, and maybe draw the uh, contour labels on a particular layer name, um, you know, different line weights and all that kind of stuff for existing contours. Well, the same command would be to draw proposed contours, for instance. And then instead of, so you'd have to go through and change the dialog box again and fill out all the different layer names and the text styles and whether or not you're going to turn this on or that on. So instead of doing that, you're going to do it once and then save and maybe call one set existing contours, and you'll save the final contours. And then when it comes time to draw it again for the next project, you just say load and you go and get the existing contour settings files, and it will populate the entire data or dialog box for you so you're ready to go with that command. Okay, so it's a big time saver. And that's really what to take away from this little discussion here is, and this little light bulb good idea note is that don't forget about those load and save buttons because they're nice and handy. Okay. So let's, at this stage, let's jump into the software and see what we've got. So let's go ahead and get things started up. And I'm going to open up my Carlson folders here. There's my Carlson Civil Suite for IntelliCAD. And it periodically checks for updates. I'm up to date, so. Okay. So you should get, regardless of which, and by the way, which, are both you guys using IntelliCAD or,
Yeah, I have the Carlson Civil 25 with 12.0 IntelliCAD or 12.1.
yeah, so you're on IntelliCAD. How about you, William? Are you,
I'm on IntelliCAD. I'm on
oh,
Carlson Survey.
okay, good. You're on server. Do you have Civil as a module?
Yeah, I do.
Okay, all right. So I just want to make sure because this being a civil class, you're going to need some of those commands that survey doesn't have. So,
Yep.
all right. So we're all using the IntelliCAD version. So that's, I just want to make sure we're doing that. So you should all come to this, what's called the start page, which is sort of a little, you know, sort of getting started area of the software and shows us our files and things. And they're, pretty standard. You can figure out their operation. And like I said, it's pretty self-explanatory. You get a list of your recent files in here. And if you got one that you don't want to show up in here anymore, like if I'm, maybe don't need this, this is a grading. I don't even know what that one was from. Of the specific client project, but so you can, right click and remove it from that list, which doesn't take it out of your um, computer. It just takes it out of this list of recent files. But some nice little things, and you can, and this list will scroll off and it will age out, and it's only the top 1, 2, 3, 4, 5, 6, 7, 8. I think 9 is what it keeps. I got rid of one, but if you want to keep one all the time, you can hit the little push pin over here and that pins it. So it will stay even if you keep adding new files to it. And you got links over here to your support, knowledge base. You can choose new drawings, open a drawing. There's news items over here and a tip of the day. And this tip of the day, I want to just take a minute to point that out is sometimes there's some really good wisdom over there, and it's, they're just little nuggets of things to be aware of that you might not know about. That either things that the software can do or where you can look for something or that kind of stuff. There it says you can change the included angle of individual polyline segments with the edit P line menu, or edit P line command rather. To start the edit polyline command, select the entity, and then from the prompt box, choose edit vertices, choose next, and the previous, and select and choose angle. I don't know what that, I don't know how that has to do with the included angle of individual segments. But as you can see, you can step through these different items here. And again, just something that's, I've stumbled across a couple of little accidental finds, just kind of get in the habit of checking those things when you first start up for the day when you're working. So nice little thing to point out. All right. So we're going to, instead of opening it and drawing, now we're going to go ahead and choose a new drawing and go ahead and let it step through the drawing wizard. So I'm going to use a template here and use a DWG instead of a DGN, which, by the way, Carlson will work with Bentley files directly. No translation needed, but I'll keep a DWG. And I'm going to choose a given template. I may have, something I want to use. I'm just going to stick with that one there as the Carlson template, just the default. And it's just pretty straightforward. And it will then take me over into my CAD system, start me off a little bit here, and as I get underway, and then it wants to have me fill out some more information here because it's in the process of helping me decide where the drawing's going to go. So I now look at the top of this, I see I've got a default drawing folder. That's its default. We set that in the settings, but I'm going to give it a specific name. And I could either just type the name here and it would go there in Carlson projects of that name, or I'm going to hit the set button to take me to the file open dialog. And this is Carlson's file dialog. You can always hit this browse button in that and get back to the what might be more familiar to you Windows uh, type of file dialog boxes. Let's see, let me get to the right one. Here it is. And so, I could look at things like that. And I've got things like down here, save as type, and you'll see if there's multiple types and all that. In Carlson's, and I'm going to cancel that and go back to Carlson's if you're not familiar with it yet, but you'll see the files of type is listed up here in this top blue stripe in parentheses. It just basically gives you, these are the types of files that you can use at this particular point of opening a file or saving a file. So you have within here a pull down list here of your more recently used folder locations. Okay, so some of these are on different different projects and such. So you can choose to go back to one if it's in that little short list. And whichever one, so if I'm looking at Carlson projects, I've got in the first box down here, I've got the files that are in that particular current folder. If I look down below that further still, it just tells me a list of my recent files. And this is regardless of the folder that they were in. These are the ones I've worked with recently. You can see there are some in different locations here. There's different places and the dates and such. This is much like a file listing, of course. And then over on the right, I've got a list of subfolders that are in that particular folder. So instead of being a tree structure like you would see in this particular configuration, like, this kind of thing, you're going to see these subfolders listed over here. So if I'm in Carlson projects, now I've gone ahead and stored up this class right here in a new folder called 2025-07-24 civil training. So if I double click that, it switches me now. I have no files in that folder, but I have also a subfolder called data sets for civil class, and I can double click that and see some files in that folder. Now, one thing that you will see, as long as your computer is set to not hide your system files, in these particular data sets from the class, you see these files here that have a period and an underscore? You can completely ignore those. Those are not drawing files at all. They have a same name as a drawing file. They have a period and an underscore, and you can see the size. They're all 4K in size. These are what are called resource files, because I'm doing all this work on a Macintosh computer. I'm running Windows as an emulator, and the Mac system treats files. It always puts a little companion file with every file on there called a resource fork that holds information about the file that the operating system needs. So unfortunately, that's included in those data sets. When you download them, you'll get them on your machine, but you may freely get rid of them. In fact, if I go out here to browse and I'm in that location now, see, I'm going to come here and you see they're sort of grayed out. So I could, right click and delete. Now, because I can't shift click delete these. I could if I were in my standard Windows Explorer, but because I'm in a file open dialog, I'm having to do these one by one. But anyway, the point is you can ignore them. And so now you see I've pulled them out of that list of little ways. So don't try to open those. You'll get an error message and all of that. But so these are all the different ones that are already here. Okay. Now we are being asked to give it a name that we want to create. So if you were to choose one of these, it's going to warn you that you're getting ready to overwrite one of your files. So we're going to just call this one, oh, let's just call it class sample 1 or something like that. So class sample file, whatever. Okay, so once we do that and we hit enter, now that's now changed up here that says, here's still our default folder, but here's our new location. You can see the file name there. And if you get it to the end and go all the way to the end, you'll see the name of the file. All right. So next we're going to set the basic settings here. We're going to use English units. We'll use a particular scale. Let's change that maybe from 50. Let's make this a 20 scale drawing. And if I change these numbers here, these numbers over here are going to change. So if I keep your eye over here on these, and if I make that a 40 scale, you see how, how those numbers are changing based on whatever this is here. So if I make it a 20, that's a 1.6, a 1.6. I make my symbol sizes 0.1, for instance. That makes that 2. Now, you may notice 0.1 as a symbol plot size times 1 inch equals 20 feet means, in terms of drawing units, it's going to be 2 drawing units. Or in other words, if I'm drawing a map and I'm going to draw a symbol that I want to be 1/10 of an inch tall, if when I plot it out as 1 inch equals 20 feet, then that 1/10 of an inch will be 2 feet. my text plot size of 8/100 of an inch, 0.08 inches, is going to be 1.6 feet on the ground. That's the height that I need. And so this is where Carlson comes in to sit between us and the AutoCAD side, is that we tell it what we want in terms of plotted inches. It calculates that for us and feeds that to AutoCAD in the background, because AutoCAD's looking for a ground distance, a drawing units. Okay, so so that's just the way. And then there's a little key. Whenever you see the words plot size, symbol plot size, and text plot size, you might also see symbol size scalar or text size scalar. When you see those, either of those terms, think to yourself, plotted inches. Okay, you don't have to remember it's not feet, it's not drawing units, it's however many inches. If you're in the English system and you say 1 inch equals whatever your scale is set to, that's going to govern how it generates text and symbols. Okay, and you can freely change that scale in the middle of a drawing. It does nothing to the size of the things you create. If you draw a line in the system here that is supposed to be 150 feet long, then it's going to be 150 units long in the CAD system, no matter what this scale up here says. This is just our currently anticipated output scale so that it can compute these numbers to feed to AutoCAD based on us answering these numbers as what we want to see them in terms of plotted inches. Okay, so just keep those two keywords in mind. The the plot, you'll see plot size and you'll see size scalar in certain dialogues. So we don't have to, once we get our settings like we like them, we can just leave them like that. We don't have to constantly recalculate these numbers, because this number up here in Carlson take care of that for us. All right. Right, clear on that part? And then the coordinate system. Now, most of us, particularly nowadays, with easy access to, public data like GIS systems, and also we're seeing a lot of, you know, GPS surveys that are using satellites to do our mapping, and we'll see drones and LiDAR scans and things like that. And they're going to be typically in our state plane coordinate system. So we have to tell it what kind of projection we are using. Now, the old-timey surveyors, we went out there, we drove a spike in the ground, and we declared that that was coordinate value 5,000, 5,000. Okay. It's just some arbitrary system. And certainly we could do all of our calculations based on that arbitrary system. But the advantage to now using a declared system that is going to match is so that we can add over top of our drawing certain things that are publicly available, like aerial imagery, in other GIS data, or surveys from, another company maybe even might have some files. And as long as they're all on the same coordinate system, they're all going to fit. Okay, so that's going to be what we most often will do. And we have right now, you can see the projection by default here is set to none, which would just be that arbitrary system. Or we can use a predefined, user-defined system, or we can use state plane 27. Now, I don't know why they didn't just include that up here, but I guess they're keeping it separate. And then universal transverse Mercator. Both of these last two are technically predefined systems, but here's what, these others, if I choose UTM, it wants to know the standard UTM zone. If I choose State Plane 27, I get a list of my, NAD 27, North American Datum of 1927, the various states, okay? But they didn't do that for NAD 83 because there's more than just that one. If I look at this predefined, user defined, now I can't pull this list down. I have to get that list from this define projection button. And I get a list of all of these different ones. And you can see I've got here as an example, let's see, I've got Pennsylvania. Yeah. So I've got right here's a NAD 83, the 2011 readjustment for Pennsylvania South. That's where I'm in Pittsburgh. That's where I'm sitting now, is just outside of Pittsburgh. And if I come down here and I see now I've got a NAD 83 Pennsylvania South of the 1986 adjustment. And I see I've got it in here 3 times, which I can really just remove the excess. All right, so so all this is that you're looking at here is a list that I build for myself of the ones that I'm going to be using most often. So those are the ones I can pick down. Now, if I don't see it there, let's see, Corey, you're in Tennessee, for instance. So I don't have any Tennessees showing up in here. But if I go down here now and choose my add predefined, this is where I finally get to all of my predefined lists. And I've got just the country in general. I've got some of these specifics. Here's USA County, Ohio, and I don't know what county you're in, William, but let's see. I don't know that Tennessee has any specific county zones. Nope. And in different places all over the world, different countries. So I'll switch back here to just my standard USA. And I can even search now. If I search for Tennessee, TENN, these are the 4 defined. There's NAD 27 also included in there, but I've got the 3 NAD 86s, the 1986 adjustment, the 2011 readjustment, and then the readjustment for the high accuracy reference network. So all of this is, we just need to make these match whatever our survey data is coming into us as. And right now we're going to probably be seeing this one most often. We used to see the 86 most often. These HARN networks are generally just more of the more geodetic type. But I would choose that, for instance, and we'll go with that particular system. And now you see it's in my list. This is the list that I got when I chose this define projection. So I could come here and then choose Tennessee. And I say, okay, and now you see it's changed it and tells me it's there for this one. Right. So then I've got these fields here, project name, job number, and project location. And all these are things that will show up as headings in my reports. Okay, so that's really not, it's not used for anything other than that. Okay, it doesn't track them in a database and all that kind of stuff. It just identifies things when you see it. If you run a report about something, you'll see that stuff show up. Choose to use them or not. I generally don't my own self, but some people do. If you're working on multiple projects, it's nice to keep that separate. There's also a little box right there that says skip the startup wizard next time. If you don't want to go through this, that's fine. You don't have to run it. I like doing it because it forces you to declare some of this stuff up front before you get started. Okay. Then I'm going to go to the next button, and it's going to finish setting some other things up, finish loading up a little bit more of the interface. And then it comes up with the next step in the wizard, which is to set a coordinate file. And again, you've got a data path and a coordinate file path, and you see the example, or when we made a new drawing file, it has gone ahead and suggested that we use one of the same name as our drawing file, and it puts it in the same folder location because I'm set to that follow the drawing model. Now, we don't have to use that, and we could use a different file. Now, right now, what's going to happen if you run through the wizard, it will associate a coordinate file with this drawing, whether you use Carlson coordinates or not. You can do an entire career worth of design without ever using the first Carlson point. Okay, you don't have to use points. But if we deal with much in the world of survey, they're awfully darn efficient and helpful to be able to use Carlson points. Now, as a little anecdotal example of taking the points idea a little bit too far, I knew a guy that I worked with here years ago. He's since passed away, but he's sort of the granddaddy of all the surveyors around the Western Pennsylvania region, and certainly a brilliant surveyor. But ask him to draw a square on a computer, and he wouldn't know how to do the CAD command to draw a rectangle. But he could traverse his way. So he would declare a point, and then he would go whatever distance the square was supposed to be, at whatever angle. If it's northeast, south, and west, he would put those in, and he would traverse his way around using points and then draw lines between those points to create a square. Got the job done. He still wound up with a four-sided figure, but that's really all I needed was a four-sided figure. I didn't need to have the 4 points, but that's the way he did it. And there's nothing wrong with doing that if that's your approach. Okay, so there it is. You've got the ability to link up a coordinate file. Now, if you do have one you want to use, let's say it's already been established, maybe downloaded from a data collector, you could just hit this set button where it says coordinate file. And when you choose that, it lets you choose one of these files. And again, there's those dot underscores you can ignore. But if you do this, let's see if I'm going to use that exercise 2 point groups. There's let me make sure. Here's this grading design CRD. That's a coordinate file that already exists. It happens to have 0 points in it. You see my little preview over here. It tells me that. Whereas these have 22, and that's got 144 points. So if I choose grading design, for instance, and choose open, then there it's that. Okay, so it's going to use a different coordinate file. If I were to hit that button there again, and let's say I wanted to make a file called roadway01, but I wanted to make it as a new file. Notice I've got new and existing buttons now. So if I said a new file, and if I chose roadway01 and hit open, it's going to say, whoop, hey, hold on, that already exists. Do you want to replace it? So I'm going to say no and cancel that. I'm just going to, leave it as it needs to be. In fact, I'll go back here and put this as class sample file. As a new one. So I'm back to where it sets it by default. Now that is currently empty. I can then import points from a data collector, from an ASCII file, and they shouldn't say current, they should say existing coordinate file. Current to me means the one I'm currently using, which is this class sample file. But anyway, that means you could import points that exist in another coordinate file and bring them into your file. Now, all of these commands that we're doing, by the way, part of this wizard are commands we can do individually once we're in the system. But I'm going to right now say none for my import. I'm not going to do any import there, and I'm just say next, and it's going to finish things up and dump me in the drawing. And I'm sitting here at, wherever I happen to be. Okay. So that was our wizard. And let's say when we did do that and we ran through that startup wizard, as we were going through it, let's say, remember that little checkbox that said skip the drawing wizard next time? If you should happen to turn that off and you'd like to get the wizard back, there's only one place to do that from, and it's here. You go to Settings, Carlson Configure. It's your third item down on the Settings menu. And once you're there, you're going to choose this General Settings button at the top left. And it's all the way, let's see, it's right up here in the top left corner of this massive dialog. This says use the startup wizard, yes or no. Okay, so that's where you turn it back on. So I'm going to cancel that for the moment. And let's come back out to here and let's talk about some of these settings and what they do. If we go to the settings menu, Carlson Configure, if you're still there, there's a number of categories here. You've got general settings, in which that controls a lot of the program behavior. And then you've got, here's that project and data folders. That's that thing that we looked at earlier in the book. And if I were to choose my subfolder setup, see, there's an example of multiple folders and subfolders to hold different types of data in a project structure. But we're going to keep it as drawing folder for now. And so, different things that work for us. Now, there's some things that are specific with what you're doing. And William, you've got, and you're probably familiar with these, the mine notes settings and the mining settings, things like that. If you look at that, this mining settings, and this works for the mining module. See that StrataCalc settings, and these are how it's going to compute various strata in your subsurface, ore bodies and such. And that's doing that. It's going to be modeling those surfaces using gridding generally instead of triangulation. Okay, so although, I mean, it may triangulate the data to generate the grid, but you're going to be left with a grid file and not a network of triangles. So again, we'll not, and you can see down here, I've specified a key material of coal, and it's got a density somewhere. I don't know if I put it in there, if it's in a library or something, but anyway, we're not going to look at those specific things, but those are ones you might want to take a look at. The ones that we will look at that we need to know about are, let's see, survey. Yeah, these top 6: survey, surface, project and data folders, and startup settings, general settings, and drawing setups. And we're not going to do them in necessarily that order, but we'll take a look at those. And we're going to actually set the stage here. We'll take our morning break, and then we'll come back and finish that up, and then get into some a little bit more fun stuff without making this stuff too dead boring. Notice the load and save as buttons down here that we spoke of earlier. That's going to help you, like you said, if you've got specific settings that you want to use. Now, notice if I say save as, and I'm just going to give it a a file name. Now, one other thing to notice here too, when I do a settings, this is a settings file, save as a settings file. So it's a configuration settings file to save right up here at the top, and it's going to have a CFG extension on it. But notice where it puts me. It puts me in my Carlson Projects settings folder by default, not in the one where my drawing is, which is, if I pull this down, that folder, okay? And that's because settings tend to be shared between various projects. So it doesn't matter what project you're on, you want to have your settings all available from one location, because you don't want to have to go back and hunt down a project where you saved a setting and you don't remember where it was and when you did it. So, and that's all controllable. And again, you can browse your way away from it and all of that, but we'll just call this one before class global settings. I'll say save. It says, oh, it's already exists. You want to replace it? I'll say yes. And it's going to save and come back and tell me that 96,390 settings have been saved. So think about that in terms of being able to configure a system. And if you got, 5 employees that need to all be set up in the same configuration, get them all set on one machine, do that save, put it on a network, and then come back to it, hit load, and go over and find the file that you want. And, it will populate that machine with those same settings, because these settings work on an individual machine basis. Whatever the setting is set to on any given machine is going to govern the behavior of things that are drawn and modified and computed based on that given machine. So I could take the same drawing file. Let's say that, Joe Schmo is over there working on this drawing that I'm going to be picking up later. His settings say one thing, but my settings say something else. And maybe he's aware of what his settings say, and I'm aware of what my settings say. And I think that my settings, might apply to something he's already done. But if he's already done it when he worked on the file, I pick up the file, I'm expecting it to be working the way my settings were, but it won't be. Okay, it will be whatever was in effect whenever he did whatever drawing or command or calculation that he did. So that's why it's important to know what these are, how they work, how they apply, and how they affect things. Okay. We won't spend too terribly much time on it. I promise we won't get too terribly bored with it that you are completely falling asleep. But I will show you the important ones and let you sort of, discover those as you go along. It's the awareness that I'm after more than anything else. Okay. So for now, I'm going to just say exit, and we'll be back here in the empty file. It's now approaching the 10:30 mark. So let's take our 15-minute break. Let's come back at a quarter till to then finish up our morning session. So I'll give you a chance to stretch your legs, get some coffee, answer an email or two, and we'll pick back up. So what I'm going to do is I'm going to stop the share. So that'll go away from your screen, and then I'm going to pause the recording. And so we're going to talk about these settings again. So, and Corey just brought up a point. Now, William, let me know, are you familiar with setting up line styles and layers and text styles and things like that?
A little bit. A
Okay.
little bit.
I don't want to go over old ground if it's too much, but if you want to see a little treatment, I'm going to sort of diverge a little bit from the civil topic list and talk about where those kind of things get created. So the first way to illustrate this is let's do this. Let's go to your points menu and let's come down to right here where it says set coordinate file. So we're going to now, instead of the one that we had that was empty, we're going to actually go and get one that has some points in it. So let's set coordinate file, and we'll make sure we're on the existing tab. Make sure you're in your folder where your data files are. And let's find that one that says exercise 1 coordinates.crd and open. Okay. So once we've done that, we haven't done anything to our drawing. All we've done is said, I want to use this coordinate file. So let's go back to the points menu and let's choose the third command down now and choose list points. So this little dialog box comes up. Just hit the all button under here where it says range of points and then hit the OK button. And you should see some points in here with values. Okay, should give you the total number listed. It'll give you the minimum X, maximum Y, maximum, and etc. All right, so those are the points that we have at our disposal. Those would be the ones that if we do a command that requires point numbers, those would be the ones that we would see. Now, let's go back again to the points menu and let's choose draw locate points. Now, just make sure that you have on these check boxes that you see here. It doesn't matter what you have as a symbol. If you want to change it, you can hit set and you can do a different point symbol if you want. Let's maybe, I'll come down here and choose triangle for that. But make sure you got these check boxes on. And then here you see that symbol size scalar. There's that word scalar. So 1/10 of an inch at whatever my plotted scale is. My text size scalar, that will be for my point attributes like point number, elevation, description. It's going to be 800, so a little bit smaller. And then down here where it says layer name, I'm just going to call this one sample points. Now, that layer, by the way, if I say select, see, sample points does not exist in my layer list yet. Okay, but if I type this name in here and it doesn't exist, Carlson is going to make that layer for me. Now, we may have to go back and change some of the characteristics of that layer. But this is going to be the layer that it puts these points on. Now, layers in a CAD file are a means of drawing things that are related to other things in that same group of things, like maybe a water line, you would put them all on a layer called water. Or for sewer lines, you might put them on a layer called sewer. And then later on, if you needed to turn the sewer lines off, but you didn't want to erase them from your drawing, then you could freeze that layer called sewer and your water lines would still show, but your sewer lines would not. Okay, but they're still there. They're just turned off or frozen. Okay, so that's why we use layers and layer membership to control visibility and selectability of our drawing elements. So it's going to make us this name called a new layer called sample points, and it's going to use whatever my current layer is now, which I look over in my properties and I see I'm on layer 0 and I've got My color, line type, and line weight are all set to be by layer, which is a special keyword that means look at the definition of the layer and use whatever is assigned to that layer. And so it's going to make this new layer now based on whatever this one is. And sometimes, like I said, if you do that, you might have to go back and change the characteristics of that layer later on, which we could do at any point. All right, so now we're going to have this one called sample points. And we're going to choose this button down here that says draw range. So we're going to do that, and we're going to read down on the command line. It says point numbers to draw. Let's draw 1-5. So point numbers 1, 2, 3, 4, 5. And then it will say drawing points, ... It says points drawn 5. And then it says point numbers to draw. So it keeps asking me for a new range. Well, I'm just going to hit enter because I'm finished. I hit enter. They've now been drawn into my drawing. Now you don't see them on my screen because of a setting that I had on to not zoom to. But if you had, we'll look up here in my point defaults. If you had this setting right here called auto zoom center for new points, that will, when you draw points, it will zoom you over to that location in the drawing. So I did not have it on. So they're drawn off wherever they are. I need to see them. So I need to do a zoom extents. So look at my view, zoom. And if I zoom extents, this bottom one down here, that would put everything. Well, there they are there. Where are they here? Zoom, E for extents. There they are. All right. So now I have points 1, 2, 3, 4, and 5, and they are in a particular layer. Now I'm going to change the characteristics of a couple of layers here. So I'm going to go to View, Layer Control. And I'm going to get this dialog box up, and I'm going to find there's that layer sample points. Notice it is set to be color red. So if I change that to be yellow, for instance, notice they've changed to be yellow on my screen. And I have these 3 or 4. Well, I've got a basic one because these were already pre-built. But I've got these layers here called point number, point mark, point elevation, and point description. Now, the point mark is the symbol. But again, I had a setting that told it not to put the symbol on a separate layer, but just to put it on this layer. So it's going to take on that color. But if I look at this point elevation, it's set to be dark blue. I'm going to click that and make it this cyan color so you can see it a little better on the screen. Now you can see that I've changed the color of the point. So that's where the point gets drawn on the entire. If I were to freeze, I'm going to go back. I'm going to show you go back to my layer control. And if I freeze that layer sample points, I'm going to come here and hit this freeze thaw button right here, and I'm going to hit the sun, and I'm going to turn it into a snowflake. And that freezes off everything about that point. But if I want to keep some things on, but let's say I want to keep the symbols and the elevations, but I don't want to keep the point number on, then I would find this point number and freeze that individually. See how I can do that? Same thing for elevation. But again, sample points, which is where I drew them, takes the whole thing off. Now, there's nothing on the descriptions. I don't have any descriptions showing, and that's because if I go back to points and list points again, just list them all. Notice there is no description for those points. They don't have any descriptions in there at all. They could. If I were to edit my points, go to points, edit points, there's all my points. Let's just do those first 5. And let's say I'm going to call these ones, let's call this one a control point. And I'll just copy that, paste, 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 paste. And let's, in fact, let's just call that one control point 1, control point 2, control point 3, control point 4, 5. And once I do that, I'll exit this, save my changes. Now you see I have descriptions. Okay. So now I've got those, all those layers, control those individually. But the thing I wanted to talk about were these styles. Now look at that text style. That is the default text style that the Carlson software creates on the fly if you haven't had it pre-built, and it uses. Now notice the 3s and the 0s and the C and the P's and the 8s and the 6. They're all sort of stick blocky looking. They're not really true circular looking fonts. And that's because it's made with that really old text font called txt.shp. It's a shape file, and it's defined using that one as its default. That was done from way back in the days when we used pen plotters and we had to move that pen around pretty quickly. And it was quicker to do that instead of trying to make it move around and make it smooth. So it had to make a whole bunch of little itty bitty segments. And it just would take too long to plot things out using a pen plotter. Well, now with our dot matrix, inkjet type output devices or even PDF files, we no longer have to worry about that. So we could use a better looking font than that. So you could do this in this fashion. You could go now at this point and say, let's go to our draw text. And then we're going to come over here. We're going to choose this command right here called set style. And when we do that command, that's the same thing as typing the word. If you look all the way down here on the bottom of our command line, down below it on the status bar, as I hover over that command, it tells you what it does. It selects the font style, such as bold or italic, parentheses, or I'm sorry, colon, STYLE. Well, that's the typed name that you could simply type at the command line and get this same command up. So if I choose set style, I get this dialog. If I cancel that, come down here to the command line and just type style, STYLE, and hit enter, I get that very same dialog box up. Now, right now I'm looking at this one that's defined with this font called Arial. It's a true type font, and it is my style called standard. Yours may or may not look the same. If I pull this down though, I see there's that PTXT, which is a text style that did not exist until I drew the points into the drawing, and then Carlson created it for me. And it's called PTXT, meaning point text. That's the style that it's going to use to draw points with. So all I need to do, if I don't like the way that looks, is I can redefine that style. I'm going to come over here and choose a different font. Instead of that TXT, see, I could use something like Verdana, or the one I like to use that I have, which makes them nice and easy to see on the screen, is Calibri Light. They're small enough, but yet still big enough. And when I say okay, And it says, yes, I'll save the changes. Notice they change, and now they look like nice, smooth, rounded kind of figures. Okay. So we're getting now to that question that Corey asked a minute ago about, where to set text styles and point styles and all that. So that's one place you can do it, and you can do this on the fly after you've done the file. All right, now let's suppose though that you get really sick and tired of having to recreate this style every time you open up a new file and draw points into it. Well, where you would do this is that if there was some way to take that new file and have it pre-built in that new file, so you didn't have to go and do it, then where we'd make that change is we put that into our drawing template. Now, are you guys familiar with drawing templates and what those are? And no is a perfectly fine answer.
I don't know.
Okay. So what a drawing template is nothing in the world more than a drawing file that has been placed in a particular folder. And instead of a DWG extension on the file name, it has a file name of DWT, meaning drawing template. But it is exactly identical to being an existing drawing. Okay. So what these drawing templates are used for is to get us started on a new drawing. And it's exactly the same mechanism as if let's say you had a file that you've worked on, you like everything's defined in it the way you like it. So you load that file up and then you immediately go and choose File, Save As, and you give it a new name. And then maybe you erase, things out of it that are in there that you don't need, and you start over, but you inherit all of those settings that have been made in that file. So what I would do if I didn't want to change this text style all the time is I would build that into that drawing template. And that same applies for all of these things. If you go to the view menu again and choose layer control, it's going to bring this up, which is normally how we work with layers. But I want to show you something a little more specific about this particular dialog box. Notice at the top up here, it says Explorer -layers. This is something IntelliCAD has that AutoCAD does not have. And this is one of the reasons I really like IntelliCAD even better than real, with quotes around it, AutoCAD. All right, these are my layers, of course, but look over here on the left. Here's where I've got layers. And I've got some blocks. So there's the block, that triangle that I stored, and there's another block that's the point number, elevation, description that I used. I've got some dimension styles, just standard, it's pre-built. You could have some already made. And layers. Now look down here, I've got line types. So these are all the line types that are loaded in this file. Yours may not be as extensive. It may only have a couple. You've got materials. If they've been defined, they have it here. Multi-leader styles, table styles. Well, right there's text styles. So remember we went to the draw, text, set style, or we typed style at the command line. This is another way to do that, is you could just choose any one of these. So here's that Calibri light. And so if I were to, let's zoom this up a little bit so you can see it here. So if I were to change that to be something like, let's find something so you can see. Heavy hand. So yeah, it looks like a thick handwritten type font. So this is doing exactly, and I'll put this back to Calibri light. So this is exactly the same as if I had run that text style command. but I've got all kinds of things, and I can even load up externally referenced files here. I've got various saved views that I may have had. So I've got text styles and line types, which is my line types right here. All of these are done with individual commands in AutoCAD. You can do them all in this one box in IntelliCAD. Okay. Now for line types, you would type, LTYP. I think, let me see, maybe not. It's a line type, right there it is, line type. And so that brings up this line type loader. You can load more line styles. I choose load. I can choose a different file. These are all the ones that are available in this file up here at the top. And I can pick from all these different defined line styles. You can choose a different line type file. So here's one that's not as extensive. All right, so and there's another one there's Carlson's, for instance. All right, so what you would do is get the ones that you normally use a lot, make sure they're in that drawing template. Let's say, for instance, I've got two in here that I usually like to use, and that's these two contours, contour and contour 2. And I just say, okay. And so now they've become in my list, they've been added to my list, and I could then pick from that. Okay. So another place to get that from is if you go to your view layer control, which is that same control here, even on this layer where you're defining certain line types. Let's say if I look at this sample points layer, which was that triangle on my symbol, and right here where it says line type, I click that and it's set to continuous right now. But if I set it to be, say, contour 2 and say, okay, and you're not seeing it because it's too little. Let's get another, let's say a dashed 2. And let me see if I have to do a regeneration. No, you can't really do that, but let's see, LT scale. This LT scale is on. Well, it's too little for right now to show you. But if I were to draw this contour 2 is my line type, if I were to draw a line, you would see that it takes on that different line style. Okay. So what this means is if you have a bunch of line styles that you'd like to have in your files, you need to make sure you pre-build them into your drawing template. And then when you use that particular template to start up a drawing, you're going to get a list of all of the layers that are defined in that template, all of the text styles, any blocks that are predefined, any line types that are predefined. You'll get those. I'm going to set now back to that as my current, but you'll get those set to be pre-built for you. So that, Corey, is where you would set those. If you need to add line styles and text styles, you can do that with those commands under that view layer control and just choose the different categories of what you need. Or you could pre-do that and save that in a drawing template so that when you loaded up the template with a new file, you would get all the things that are defined in that drawing template. So they're very powerful and very useful to save you a lot of time. Some people aren't even aware of them. They never use them. They sometimes will just load up a file and then do a save as, or they'll just take all the defaults.
So how do you save it as the template?
When you choose save,
Yeah.
you would choose Save As, and down here at the bottom, you would choose an AutoCAD drawing template.
Okay.
Okay, or and when you do that, notice when I do that. No, it didn't switch me there. Never mind. But normally when you have a drawing template, it has to go in a particular location, and that location is here under paths and files. If I look at my template paths, I've got my drawing templates. It's a list of folders here, and this particular one is going to go in C users, my name, app data, roaming, Carlson software, Carlson 2025 AK 12, blah, 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 X64 backslant SUP. So that's the support directory. So as long as that template is in that folder, it's going to find it. And when I say it's going to find it, here's where it finds it. So let's just go to the file menu now and choose new. And you should see this. And I give you the option of choosing existing template. If I say next, template name. Now here's where I've got predefined templates. If I were to choose browse, it lets me go out and find it from another location. But this is the location it gets it from. And I've got a couple of here. Let's see. Here's my CAD National CAD Standard Civil, National CAD Standard Survey, all these different ones. Here's a National CAD Standards Survey and Civil. I've got one here called Test Template. Let me see my AWK Carlson template. And then I say finish. I'm not sure what else happened in this particular template file. I'm going to just exit that at this point. And if I look at my layers now, notice all of these layer names. I've got things like existing easements, blah, 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 blah. I've got these plans, et cetera, text viewports. And, I've got different line weights. I've got different line styles, different colors. So they're all pre-built. And if I look at my text styles, I see I've got these different text styles available to me. Notice PTXT is not in here, so I would have to fix my points again, to change that if I wanted to. In this case, my standard style is built using this simplex instead of that aerial that you saw in that other one, as an example. Now, here's another great little reason I like IntelliCAD is because notice I've got two drawings open. I've got my one with the points here, and I chose it up here at these tabs, class sample file. Here's my new one called drawing 2. There's nothing in it. And notice these things are changing here. If I sit on layers, that's what is in my current file here, all of these layers. And over here, what happens is you see however many drawings you have open, you're going to see them listed over here. The one that is in boldface will be expanded. That's the one you're currently in. But let's say that I wanted to look at these text styles, which are down here. There is no PTXT that I liked with that Calibri. So what I can do is I know I've got it in this file, so I can just open up this plus sign, sit on that text styles category, select my PTXT, and just drag it and drop it on the same category name in the other file. And so once you do that, now I'm going to switch to that file, and you see now I have that right there. Now notice there's one called Standard Simplex, and if I come back to here, I've got Standard made with Arial, and if I try to do that one to text styles, I think Yeah. So if it's already defined, it does not overwrite it. That's why it kept it as simplex. So this one I would have to change, to be, if I wanted it to match, I would choose Arial. Okay, but I really like
It
this
actually,
graph.
you put a copy of the standard at the top.
Oh, yeah, there it is. Yeah,
Yeah.
good eye. So then what you would normally do is you'd have to sit on one, make it current, and just double click it. Select the one that you no longer want and choose. You can't delete the text style standard. Okay, so that's a predefined one. All right, so in that case, yeah, so if you were to get a duplicate, it will give you that copy, and as long as it's not standard, you can delete and rename and all that kind of stuff. Okay, so it's a really convenient tool, this thing, and it's all called under the view menu called layer control. Because in AutoCAD, the AutoCAD version, all it does is bring up the layer dialog, and it doesn't have all these categories over here. So that's why it's called view control. It's called layer control. But in Carlson or in IntelliCAD, it brings up this Explorer, which gives you all of these different controls all in one handy spot. So keep that part in mind, and you can work on these templates. So now that I pre-built that text file, for instance, I'm going to go to now set my coordinate file. I'm in my new drawing now where I transferred that style to. I'm going to choose where am I? Some Carlson projects. Let's go down to our 2025. There's our civil class. So here's that exercise 1. That's the one that we used before, 22 points in it. So now I've opened that file. And I'm going to look down here. I'm going to set my auto zoom is on. I'm going to use circles this time. And I'm going to say draw, locate points. I'm just going to say draw all. And it drew them all in there. And now notice my text styles are different. They're using that new defined style. Okay. Now, one thing you may notice here too, look how those circles look like stop signs or something. They're not really circles. And you can fix that if you notice your circles are turning to look like that, or arcs are starting to look chorded. You could do a regeneration of the drawing, which is RE, and then you see that would do a regen, or you can regen all, which would regenerate any of these additional layout tabs. So when you do that, you notice how it changed into looking at smooth circles again. And that's because of a thing called it represents circles in the system using a display list, and it calculates out, let's say if I'm at this stage, and let's say let me zoom everything here, and if I do a regen at this level, and now if I zoom down tight again, you see how they're square, because at this stage, visually they look like circles. So AutoCAD and IntelliCAD draws circular things with chorded pieces, only using only as many chords as it needs to represent that as a circle at the level that you're viewing it. Okay. So if you were to zoom in real tight and you see they look like that, you can issue a new regen. You can just type, RE and hit enter. Sorry, RE. It's supposed to be regen there. It's using redo. That's because it's in one of my quick keys. So I just spell out the whole name, regen, and it regenerates it. So if I usually just do an REA to regen all. Now I zoom in here and it's back. Now there's a setting that controls this. And I'll show you that setting. And it's under settings, IntelliCAD options, display, I think. Let me see here a minute. No. Let's go down to settings, IntelliCAD settings, and these are the drawing settings. There we go. So the drawing settings are the ones that store individually with the drawing itself. And I've got a display tab here as well. And I've got these tabs across here. Let me see where it is. I know where it is in AutoCAD. Line weights. Nope. Well, let me see. If I look at a system variable editor, I know I can find it from there, and it's called view res or view resolution is what it stands for. And I don't see it here either. I wonder where they put it. Let's see here a minute. Drawing aids. Sure don't see it. Let's see where they put it. We look for view to you. View center direction mode size. Let's retain its max. Huh. I don't see where they've hidden that in IntelliCAD, but anyway, the name of the variable is this, view res. Now, let me look at the help and see if they tell us where that's going to be stored. And see there, you can see the picture. There's a low precision, looks like a stop sign. The high precision looks like circles. They don't tell you where. Where it's stored. See, it's under the view manager. Well, it just looks like it's a system variable. But anyway, if we type view res and hit enter, it's going to ask if you want fast zooms. We'll say yes. And now the curved display quality, the range goes from 1 to 20,000. So smaller numbers means it's going to be more corded because it's going to, and it displays things faster when it's in those lower numbers. But even a file with thousands of circles in it, because computers are so fast nowadays, we don't need to worry about that setting so much anymore. So I always type that up to the full maximum of 20,000 and I hit enter. Notice they're now circles. So if I go way out here into a regen all, Now, if I zoom back in on my circles, you see they're still looking like circles. And I have to get really, really tight before and I can't even get tight enough to see the chord. Okay. So that happens to be an AutoCAD system variable. And it's available under the AutoCAD options, but I don't see it listed under the IntelliCAD options. That's why I was looking for it here. And it normally would be on the display tab. Cursor color mouse toolbar, fade control font. Oh, graphics performance. No. Well, I don't see where it happens to be in their dialogues, but that command called view res, VIEWRES, sets that. Now that happens to be a variable that stores with each drawing. That's why I was thinking maybe it was under IntelliCAD drawing settings. And I looked at it here and I still didn't find it. Let's see, display. My drawing limits, which is similar but not the same. Line weights, grips, program interface and viewing. Yeah, see, nothing that tells me there. And then I thought, well, it is a system variable. So I look under here under IntelliCAD settings, the system variable editor. And these are listed alphabetically and it's called view res, but there's nothing there that says view res. I suppose I could. Yeah, redefine those, but yeah, they're just not there. So yeah, that's one you just have to remember the name of it. But because it specifically stores with each individual drawing, I like to predefine those in my drawing template and set that variable to 20,000. Then when I save that template file, that goes along with that. So when I create a new file, it will create that new file with that same value that I've set with view res, which I set up to 20,000. Okay, so none of that stuff really matters or is important about getting your Carlson work done. It just helps you, display that. And sometimes if you're not aware that your circles might start looking like stop signs, then, you may think there's something wrong with the drawing and you'd have to go in and you constantly are trying to, edit that blocky looking figure and turn it back into a circle when it really is a circle. So uh, just be aware of that particular one. It's unfortunate that AutoCAD uses display list processing still in today's day and age, but that's just one of the legacy holdovers from the early days you have to be aware of. Now, that's also something to be aware of if you open up a file that, let's say you got a file from a survey or another company that did survey work for you, for instance, and they've drawn some circles and arcs and things in there. And if you notice, they're looking sort of blocky and corded and shouldn't be, then check out that variable called view res and set it accordingly, because again, it stores with the drawing and not with AutoCAD and not with your installation of AutoCAD, but it stores with each particular drawing. So that's a good candidate for putting in your drawing templates to get things started with. Okay. Now, one other, I'm going to close that little drawing two and not save the changes. I'll back to my original drawing. And if I do another drawing. Let me see if I've got any of these. I'm going to browse to a different location. Where am I going to be? Carlson. Got my AutoCAD. Let me look. Let me see. It's not there. Let's see here. Well, I have no idea where they're putting them. I'm trying to wanted to illustrate a particular point here. I know of one. Let's see. It's going to be here. Consulting, CAD resources. Don't even see it there either. Let me see. Is there anything under Carlson? Nope. CAD resources. Well, not knowing where they stored, I'm not gonna waste a lot of time tracking them down, but here's what can actually happen in your drawing templates. Let's say I'm going to open up a file that I've got done here. Let's see. Something. Let's see. think this will be it, yeah. All right, so this is a particular project that I worked on for a client uh, several years back now. And normally we have, like if you notice in our file, this class sample, I've got a model tab and a layout tab, which is just a sheet, a given plotted sheet. Okay, so if I go back to my design, here's my model. This is all the actual geometry in the file. But then if I look at these individual sheets, I've got a title block, a blank title block set up. There's with my, you know, utility, the PA1 call before you dig kind of stuff. It's got my stamp, my signature, placeholders. It's got my logo and stuff here and the surveyor that I worked with on the job. Uh, you know, sheet numbers and titles and dates. All of these things, you know, are pre-built. That's a blank sheet. And here's one and that's in ANSI D size. That's 22 by 34. Here's architectural D, which is 24 by 36. And then these are all individual ones that I've, uh, you know, done for this particular project. But what I'm getting at is you could have in your drawing template file, you could have any number of these. Let's say we had these blank sheets and maybe we had them in 4 or 5 different sizes. So we could pre-build those, save that as a template file. These come right along with it. Then when I start a new drawing, I would get this stuff coming in. I wouldn't save all of these other ones here, but I would save the ones that I wanted. Okay, so when you build your template files, keep that in mind. If any of that stuff that you don't want to have to set up each time you do a new file, pre-build those in your templates and they'll come in already made for you. Okay. Now that's not a process that happens overnight. You know, it took me, you know, years to get it done. And I get even to this day, I find something that I get tired of doing every time I open up a new file. And so I pre-build that and load it up into a production template file that I want to use when I start my drawings. Okay. So that's where you set those settings. Now, let's talk about these other settings here a minute. And then as we get, we're getting closer into our lunch break here, but I want to get this done and out of the way. So let's go to settings menu and choose Carlson configure, third one down. And these are the ones that we're going to be looking at. And we're going to just sort of gloss over those other things there, but here's a couple of ones to pay attention to. On the survey settings button, even if you don't, well, it won't matter if you don't have survey, but if you do have survey, here's something you might want to check is this top box that says CG survey menu. It used to be by default, it came in and said compact. And if that's the case, now you can leave yours sitting there. I'll just back out of here and show it to you. And if I switch to my survey module, so I'm now in the survey system here, and I come over here and I see this menu right here called CG survey. And this is an entire implementation of the old Cowherd and Goodman survey software. And Carlson gave that as a convenience to the clients. When Carlson bought CG Survey, the company, they rolled all that stuff into their product. And a lot of the clients that were using CG Survey then had to use Carlson Survey, but they were familiar with these commands and not Carlson. So this gives them a way of doing the commands that they were always familiar with using. So if you don't have a need for that, then I would suggest that you look at that survey settings and pull that down. If it's not setting on none, turn it to none so it goes away. then when you say, okay, then that menu is going to disappear. See, it's gone now. All right, so that's the survey setting ones. Make sure it says none. Okay. The surface setting one, the ones I want, these up here, William, are going to have some effect in your mining software setups, but they're also handled in the mining setup. So you don't need to worry about them here necessarily. But what I would recommend that you do have on is that you have these bottom three check boxes on so that you can make 10 file edits and it will save those edits to let you reapply them later if you ever need to. Not something that I ever really do much, but some people do edit their 10 files directly. And so they need to track that history to be able to reapply that. So make sure those three are on and say okay. So that was surface settings. Now, here's those project and data folders that we talked about earlier, where we could choose those particular subfolders, and then we could assign all of these different data file types to particular folders. You know, so here's my coordinate file, or you're going to go in project data points, deed points, you know, just whatever you assign them to. Now, this is a little trick that can help you with something here. Let's say you always work in this drawing folder format by default. Well, let's say you then find a file that was, say, you know, you see a file and it has an extension on it of a .cl, and you don't know what that file means. Well, you can come to this settings, which is under Carlson Configure, Project Data Folders. Temporarily now, we're not ever going to say, okay, we're just going to switch over here to project folder and then choose data type subfolders. And we're going to look at this, and we see that if unless we're, you know, broken out by category, we'll just go to all categories. Then scroll all the way down to the bottom, you see there's 270 some files in this implementation of Carlson. So, and they're all, you can sort these by clicking on these different categories. So, and then click it again. So now it's alphabetically sorted. And right here is that, oh, there's that CL file. And you look over here in this description, it tells you that's a centerline file. Same thing if you found a file called, you know, CIN, it's a culvert inlet library file. And you could see, and they're all defined with what the file is in the description column. So I can say, oh, okay, now I know what the file is and know what to do with it. I'll just hit cancel, and I'll hit cancel so that I don't change it and I keep it sitting on my drawing folder. Okay, so that's a nice little trick if you ever need to see what a file is. Now, these next two that we're going to look at, the startup settings and the drawing setup. The startup settings are just some defaults that are going to come into play as soon as you start the software. One of which in the lower left corner, if you don't like Carlson's little flashy screen when it loads up, you can suppress that right there to skip it. And the IntelliCAD command switches right there says /no logo. That does the same thing as this skip splash screen does for Carlson. This does it for IntelliCAD. Otherwise, you would see the IntelliCAD screen as it loads as well. The profile name is set when you install the software. I would leave that alone. You could switch it to a different saved profile, but there's no need to worry about that yet. And then here's where the project folder default location is. So let's say you keep all of your projects on a network drive called P. You know, you've assigned it letter drive P. And you've got a folder there called engineering projects. Well, then instead of starting in Carlson projects and having to navigate over to that place every time you start to look at files, just go ahead and set the startup to be drive P : engineering projects / and that will let you start in that location. You can browse to it and find it, or you can just type it, either way you want to do it. Okay, so that's your starting point when you start the software. The template name is that list of those templates. You see that we saw when I started a new file. And so right now I've just got it set to the default of Carlson DWT. But if you spend some time and effort and you set up a template you want to use, then just change that and choose it. And notice it's in this folder here under users, your name, app data, roaming, Carlson software, blah, 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 support folder. Okay, so that's where that's going to look by default. That's where this one's pointed to. And you could choose one of these to be the one you want to use when you start up. Okay, just by default. Now, again, that can be, notice right now it was pointed to my individual machine in my particular settings. So if you don't change that and leave it, pointing to that location, then that's where everybody's is going to start looking. If, however, you've got, 5 or 6 people using the software and, you want them all to use the same drawing template, we'll throw them on a server somewhere and point everybody to that location instead of to their local individual settings. And I would even at that point and go ahead and choose OK to set that. And then leave this up for now. But what I would also do if I change that to a location for there is I would go to my IntelliCAD options under settings and paths and files and come down here where this template path is. And I'm looking for templates. I would change this folder location. Right now, that's the default. Drive C, users, username, app data, roaming. I would point that to a location, that common location on the server somewhere that you want everybody to look at. Okay, so do it there as well so that that's the default according to IntelliCAD. Now, finally, let's come back to our last one here called, or I'm sorry, we're going to this one above it called drawing setup. And this is when you go through the wizard as you're starting up, these are going to be the defaults that you want to use as you start things up. Again, the point attribute layouts, whether you're using descriptions, elevations, place them on the real Z axis at their elevation, labels, 0 elevations, even if you have no elevations, you don't want to suppress that necessarily. So these are, again, just defaults that you're going to be using. And when you tell it to drawing setup source on startup, there's 2 different things here. One is to use the drawing template, and that doesn't mean, I mean, it's always going to use the drawing template, okay, if you choose a template. But what this means is, what do you want to use to fill out these numbers and these choices? If you use what's stored in the drawing template, it's going to take whatever default settings are in that drawing template. But if you use this configuration, that means the next time you start up a new drawing, you notice mine said 50 because that was what my template was set to. But if I use this configuration, anytime I do a new drawing now, it's going to be 20, vertical scale of 4, so a 5-time vertical exaggeration. There's my symbol size of a tenth, my text size of 800ths, a symbol name I would set to use typically, right there's that SPT 9, that's a plus mark. My attribute layout ID, I've got default is 1, where the point number is centered over the point. The elevation is off to the right and the description is centered underneath it. I like to use this number 2, where the point number and elevation and description are all lined up left justified to the right of the point, the way you see them out here in my drawing, the way I drew them in. Okay, so that's the difference right there as to whether if you use the drawing template, it reads all of this stuff from the template and uses it, or it will read it from here and apply it, even though it's still loaded up the drawing template. You got all the layers and line types and text styles and all of that, but you want to use the configuration if you want this to always be what you start with, okay? And then you could predefine your coordinate system. Like I would normally set mine to a predefined system, define the projection and find that Pennsylvania South right there, that one, the 2011. And so by default, that would be, because I do most of my work in that part of the country, so that would be what I would set it up to use, okay? And I would say, okay for that. That means that anytime I do a new drawing, that's going to take that data from this, use configuration, instead of reading the drawing template to get that information. So I've switched mine now. Now notice what happens if I were to say exit here. It says, okay, you had some drawing setup change. Do you want to apply that to the current and future drawings or only to future drawings? Well, if I say current and future, then it resets that to my scale and everything else. All right. Which would be under this settings drawing setup. That would be again where we set all that stuff accordingly. Now, let's go back one more trip to drawing or to settings, Carlson configure, and we got one big button left, our general settings. And we'll tackle this stuff a little bit in a little bit of detail as soon as we come back from lunch. We won't spend a lot of time on it, but for now, what I'd like you to do is set this up exactly like you see it here. And can you read all that stuff? Is it large enough to read for you?
I can see it.
Okay. You guys are young. Good. All right. So set all that stuff up to match. If you happen to be using a slightly different version, if it doesn't look exactly right, don't worry about the ones that you don't see, but the ones that you see that I have, go ahead and set, and then we'll talk about them when we come back after lunch. I'll give you a few minutes on that.
Yeah, just a second. I'll
Yeah,
get it.
take your time. I'll just leave this up here till we, till we break at noon. So you got 3 minutes or so.
Okay. Two. So the annotative scale prefix and suffix, I can't really see those, but mine has just a colon in the top on the prefix, and then I can't.
Yeah.
Does that
Well,
matter?
it doesn't, but if you want to match mine says it's a inch mark,
Okay.
space, equal sign, space. For the prefix,
Yeah.
for the suffix, it's a foot mark, a single
Gotcha.
quote. So double
Gotcha.
quote space, equal mark space for the prefix, and a single quote for the suffix. I'll show you what those mean when we get to them.
All right. I should be good.
All right. William, you got yours set as well?
Yep, I'm good.
Okey doke. Well, go ahead and choose OK for that and then choose exit. And then if you want, you can save your drawing. And it will just take whatever those 5 points we've got in there now. And we're going to play around with that when we come back and talk about these settings and how they affect things. So, and then we need to, after we get that done as quickly as we can, we'll jump into the civil stuff because, this is really stuff that we would get, in a lot of depth in the fundamental side of things. But so for now, get those set, and then we'll talk about what we need to, out of that dialogue, there's not a whole lot that you need to try to remember and keep your mind on, but we'll talk about the ones that do matter, the ones you need to be aware of. So, and we'll see their effects when we try some different things, okay? So with that, that'll be a great place to go ahead and take our lunch. So I'll stop our share, and then I'll pause the recording. All right, so we left off before lunch here talking about our settings. So let's go back to the settings menu and look at Carlson configure. And it's this big general settings. And there's a couple of them here to be aware of and important. Again, the first one that we talked about was if you want to use that startup wizard when you start a new file, this is where you can turn it on in case it got turned off from a previous time before. This ignores zero elevations, for instance, is one that if you, when you go to build a surface, Carlson is going to look at everything that has elevation information in it. And there's two ways of, getting that information into a surface computation. And, you have to select the elements that it's going to look at to model. And if you have some things drawn that are just plain down at zero elevations, if you have this checked on, then even if you were to draw a window around everything and select all of that information, if it has zero elevation, it will not be used. Otherwise, you'll get, let's say, all your main 3D line work is up in the, 700 or 800 foot elevation. And if you also select something with zero, and if that switch is not on, then it's going to try to triangulate down to that zero level. So it's just a convenient way to keep you from having to, be more selective in your selecting entities. So it's just a convenient switch, basically. All right, and now this annotative scale prefix and suffix, I'll show you that in a minute. All that is when you set a scale in the drawing, and if you tell it down here to use annotative scale, and you select your active scales, then remember when we were first starting this drawing, I started it off with 1 inch equals 50 feet. And then I switched it to be 1 inch equals 20 feet. So it created these as specific annotation scales that I can use. And that's going to control things like annotative text sizes, that the text will resize itself when it needs to, if you change scale, if you have annotative text being placed. Otherwise, you see the ones that have the colons in them, that is the default that you have set there. And these are the ones that the that IntelliCAD has pre-built as part of its new, or part of creating a new file. These are just some common scales. And now the reason I like to use inch, double quote space equals space, and then a single quote for the foot mark, is that when you see a scale listed as a number and a colon and a number, that is typically a metric scale. It means like, 1 to 100, for instance, means, 1 centimeter on the paper will be equal to 100 centimeters on the ground. 1 centimeter equals a meter, for instance. Um, so, but the way the CAD system looks at it is one drawing unit colon however many paper units. So if it's plotted and we're in inches, then 1 foot on the ground, or I'm sorry, the one is 1 inch on the paper, and then the distance, the bigger number is the distance on the ground. So in that case, it's a paper unit compared to a model unit. So it would be 1 inch equals 30 feet. The one I'm pointing to right here, this number 7. Or I can use, what to me, I would have liked to have seen it as 1 inch equals 30 feet. Now, I don't have to go here and redo all these things, because when I tell it over here to use annotated scale, then anytime I go to my settings and set my drawing setup and change the scale, it creates that for me on the fly. Okay, so that'll take care of that. And that's why I like to use these different prefix and suffix values to make it look like exactly what I'm looking for and not that particular colon separated value. All right. Now, the other ones that we need to talk about, if you've got these things set here, that's all fine. The coordinate format will be Carlson alphanumeric. That gives us the most flexibility. We can have numbers as well as letters in our coordinate number, in our point numbers, so to speak, the point name. And these other ones are just the Carlson numeric only means it would only allow numbers and no letters. And that's the old format that it used to use. This SQLite or SQL Lite, what they call SQLite, that's a structured query language. It's a small, sort of a light version of it. And it makes a CRDB file extension, 4-letter extension. And all that is a particular way to store the coordinates in a file so that you can have all of the GIS data, in case you are collecting GIS data, to be stored within the same file as the coordinates themselves. Otherwise, you can still collect all the data if you're doing that, and it just goes into separate files of the same name, but with an extension of .gis. So you can still use GIS data. It's just a convenience switch. If you're always collecting GIS information, you can have that on there. Now, I'm going to skip this object linking part here for just a second, and we'll talk about this removing arcs offsets, and which method we want to use. So what that means is when the system has to convert an arc, a true circular arc, which lies in a single plane, in the horizontal plane. If we want to turn that into a 3D element, so think of like the edge of a road turning into a driveway, and there's a little, what's called a curb radius, or a curb return, rather. It's that little, little tangent arc that connects say, the edge of the road to the edge of the driveway. So if that happens to be, in 3 dimensions, it's got actual elevations along it, then we need to convert what would normally be drawn as a circle or an arc. We need to give that elevation, so it now no longer lies in that plane, and so it now technically is no longer an arc. We still see it as such because we're looking at it straight down in plan view. But the only way that the CAD system can represent that with elevation, with differing elevations, is to replace that arc with a series of connected chords. And this method is simply, if I were to, I'll draw you a little picture here. You can leave this up for yours, and I'll show you a little picture of what's going on. So if I were to draw, let's say, arc. Let's see. Say like that, if that were be something, and that's an arc. So if I were to, let me give this a bit of line weight so you can see it here. So if I need to convert this, you see it's an arc, and there's a vertex point here where it starts. There's a midpoint, but it doesn't store that. It just calculates and shows it. And then there's an endpoint. But to turn that into a 3D arc, I'm going to make a copy of this now. I'm going to select it, right click and choose copy. And I'll just copy it up here. Well, better yet, I'm going to offset it so it'll be perpendicular. All right, so there's the true arc. Now, if I want to give this elevation, I'm going to make this one red. Let me show you the difference. So if I have a number like this, I'm going to change that to be, let's make it 2 feet for a maximum offset. And exit. And now I want to give that some elevation. So I'm going to go to my 3D data menu, and I'm going to come down here and choose 2D to 3D polyline. And I'll just do it by start and end elevation. So I'll choose this, and I'm going to start it at elevation 100. And all the way around to the end, I'm going to change that to where it goes up to 105. So it'll be a convenient change. Now, look what happened. And you can see this, if I offset this back, there was the original. This one was the converted 3D. And you can see that like right there. See how it's up high and the others are down at 0. So when it converted it into a 3D element, it has to do it with a series of chords. So it honors the endpoints, but then it calculates the number of chords that it's going to need based on those values that we saw in this right here. Now I put that maximum offset as 2 feet. So what that means is the maximum amount that it can be off of the original arc is 2 feet. So it used as few of these chords as it can to where this distance is 2 feet. Okay. If, on the other hand, let's see, let me cancel that. Yeah, we'll leave that one red. We'll make this one green. And then we'll go back to the figure Carlson, and we'll change that to say 0.5. And then we're going to repeat that 2D to 3D by beginning and end elevation. We'll select that green one, and it's going to be, say 105 at that point and 100 at that point. Okay, so now you see I toned down, and this is the original. Original arc was that white one, which had the original circular arc, but then the 2-foot max offset was here. And then whatever I changed that to this time, I forgot what number I used. I used 0.5. Now I'm going to set mine back to 0.02. And we're going to talk about what this means. So what this means is that, again, you see that's half a foot here. The red one had 2 feet. So 0.02 feet then will be like this. And let's make this one magenta. And we'll do the same thing there, 2D to 3D, by start and end elevation. It'll be 105 and then 100. So now, if we take this original, offset it back, you can see there is much tighter, okay? And so if I select that, you see the number of those little blue blips, those are the number of vertex points or vertices along there. And the green one, it's fewer, and the red one is fewer still. Now, what that means, what the implication of that is for our work is this. First of all, we want to try to mimic that arc as closely as we can without getting too carried away, because when we go to model this into a surface, every one of those points along that line is going to be the corner of a triangle. So if I have that number set to something really stupid small, like 0.00000001, I'm going to get hundreds and hundreds of those little vertices all lined up, and it will form that many triangles. It will be a huge number of triangles in all these curves. Whereas if I have it set to something big like 2, I'm only going to get these triangles forming here. And so if you were then to take that resulting surface that you've modeled, maybe that's a design, and you go out there and try to build it with, you know, a machine control or something that you put on a dozer, and you go out there and try to build it, it's going to honor the placement of that red line or that green line or this magenta line. So you can tell if it follows that magenta line, that's going to be really close to what that original circle portion was. In fact, 2/100ths of a foot difference is hardly detectable, you know, even out there on the ground with a tape measure. It's going to be hard to see, but I don't want them to be so small that I get a bazillion little triangles in there, because that's going to be unnecessarily dense and just take too much processing time. So that's what we're looking for, is a good happy medium. And those are the numbers that I found work the best. And I like this method the best. The other method is to use the chord length instead of the offset. And that chord length would be, you know, the length of that green line or that red line or those little short magenta lines. So it would compute it using that. But I'm telling it to use the offset and to do it within 2/100ths of a foot. Okay. So that is what that section down there means. And it's usually a set this once and forget it kind of thing. Okay. But if you should get something and you notice that your modeling is missing, you know, where the 2D elements, it's not really replicating them very well, very closely, then that would be where you would look for that situation. Now, these object linking sections, these are all should be fairly self-explanatory here. We link up points with the coordinate file, which means if we've drawn points into the drawing, and then if we move the point location in the drawing, if that link is on, it will automatically update the value in the CRD file. Now, that's really becoming an obsolete setting at this point because it caused so much trouble before that Carlson wrote in a little warning message now that regardless of what this is on, it's going to tell you when you're in a conflict, when you're in a different position in the drawing versus in the coordinate file. And it will ask you then to confirm whether or not you want to update the value in the coordinate file after you've updated it in the drawing. So it will now prompt you for that. So that really is almost a redundant setting, but it's there. The next one is to link line work with points. And that means if you draw any kind of line work using one of the Carlson draw commands that allows you to use a point number as a location to connect, you know, point to point to point, then if the point should change position, the line is going to automatically follow where that point goes. Okay. Linking labels with line work, and a label is something that you're going to generate from the annotate menu. Things like a bearing in the distance or curve data, anything like that, or maybe the area of a closed figure. So those are all labels. Stationing along a center line alignment, for instance. Those things are all labels. They're not just, I mean, they are just pieces of text, but they were created using the Carlson labeling commands, the annotate commands. So with that on, if the line should happen to change shape, then the labels will recompute and redisplay. The next one is whether to link line work with center lines, meaning if you've created a center line from a polyline that's drawn in the drawing, then if you change the polyline in the drawing just by a standard cat edit, maybe you just grab a grip and move it, it will automatically go into the centerline file and update the values in that stored file. Likewise, if you should edit that file, make a change to it, say maybe shorten the length or give a steeper radius on a curve or something, and then if you save the file and when you exit, if that switch was on when you did that polyline, then it will redraw the polyline based on the definition in the centerline file without you having to go back to the centerline menu and choose draw centerline file. It will just automatically take care of it for you. Okay, then grouping the point entities is going to group together when you select any part of the point, like the elevation label or the symbol or whatever, then it selects the entire group of things that make up that Carlson point. And there are three things that make up a Carlson point. There is a CAD point entity, which is like a line, circle, polyline, what have you. And there is a symbol, which is a block. It's a drawn block. And there is another block which holds the labels. Those are called attributes. The point number, the elevation, and the description. Okay. So all that means is it's just going to take all those together. And then maintaining the coordinate history file means you can actually do a bunch of stuff and edit points, move points around, make changes to points. And it keeps a running list of all the commands and also the user who did it and the date and time and all of that, of those changes. Well, if you keep that history file, if you maintain that history file, then you have the option to then go back and undo back to a certain point in time where you started to make some alterations to the coordinate file. Let's say somebody moved 5 points, but they didn't, they weren't supposed to. Well, then you can roll that history back and reset it back to where it was before that happened. Now, unlike the undo command in the CAD system, which undoes those operations, and that would also undo those changes if you moved a point around and you wanted to reset it. But undo also undoes everything you've done in the drawing. Like if you alter some points and then you draw 2 lines in a circle, if you undo, and then undo the change to the points, then you've lost all of the things that you've done since the time you made the point edits. So any kind of additional stuff, it also undoes. That's why this is useful, because it only works on the coordinates themselves, not any intervening CAD commands or creations. Okay. So that's how they work. Now, here's the thing to keep in mind and be aware of. These switches, these settings, these links work on things that you create in the drawing. And the linking behavior is set based on whatever this switch is. If it's on or off, then the linking behavior for those resulting things that you've created behaves that way. It's whatever the switch setting is at the time those things were created. So let's say I've got linking on right now with linking labels with line work. Just like leave them all on there and go ahead and say okay and say exit. And then zoom out here to the where your points are. Okay. And let's do this. We're going to use a Carlson draw command. We're just going to draw a polyline from point 1 to point 5. So if I were to draw that with my CAD system, I would have to draw a polyline, and then I would have to snap and snap and snap and snap and snap to get those point locations. Or if I choose a Carlson draw command, let's just draw a 2D polyline. So I'm going to the draw menu, 2D polyline, and I'm going to just use my current drawing properties will be fine. Or maybe I'll uncheck and I'll select this layer called final. Maybe that'll work. Then I'll say, okay, now it says pick a point or a point number. So I could just, I could pick points here and go here and say, maybe come down to that end point. So see my end point snapping comes on there, that little red marker. So if I snap to that end point, and now if I want to go 1 to 2, so I'm going to say, notice it says pick a point. Now I've just been picking points. I picked a point, I picked a point, I picked the end point, and now it says pick a point or a point number. I'm still going. So at this stage, I could type 1, hit enter, and it draws to point number 1. I'll type 2 and hit enter, and it draws to point number 2. And maybe this time I'm going to just snap to that end point there. And now again, pick a point numbers. Well, I can say 3-5, so it will take the whole gap from 3 to 4 to 5. The gaps also work backwards. If you draw, let's draw another line, and we'll change its layer just to make it different. I could say 5-1. Whoops, but let me see, I'm going to say, do that same thing. I'll pick up a couple points out here, and then I'm going to say 5-1. And then I'll pick a couple of other points out here. And so now this is, well, let me set my line type scale better. There we go. So you see the range of points by using point numbers, I can go, forward and backward in those numbers. So that's a couple things that I've done. Now, because I had on that setting to link points with line work, watch what happens if I were to move, say, point number 3. I'm just going to move it on the screen. I'm going to select it. I'm going to then sit on that grip till it locks it, and then I'm going to go over here and I'm going to move it up to here. There's that little warning. Said, do you want to update the coordinate file for that modified point 3? I'll say yes. So when I did it, the lines went with it. Okay. Now, let's go back to settings, Carlson, configure general settings. And if I uncheck link line work with points and say okay and exit, now you would expect if I move another point, I'll come down here and change number 2 and say yes. You would have expected that not to have come with it because it was unchecked. So that's what I want you to understand is that these lines were created at the time that that switch was on. So that switch is going to be on for these lines always until I change something about them or delete them and recreate them. Now the switch is off. If I draw another 2D polyline, and let's just come here and go dink, bink, and we'll say 1-5 and be done. All right, so now if I were to move point number 1, yes, I'll update it. Notice the line did not go with it. It didn't follow the point because the linking was off when I created the line. Go back to Carlson configure, general settings, turn the linking back on, and now again, if I move, point 1, yes, updated, it still doesn't pull it around because that linking was not on when I created that file. Now, I can put it back, just manually, and that's what I would have to do, or recreate the line to establish that linkage. Okay. So that's one way. Now, the label linking, for instance, if you go to your annotate menu and choose auto annotate and just take the defaults and say okay and select the line. And there you can see it's calculated my bearings and distances. So what happens if I change this polyline now? I'm going to just grab that grip and I'm going to move it down here. It redraws itself, but it also recalculates the new bearings and distances and, follows the change. Likewise, if I've got some figure, let's say maybe we'll make it a closed figure. Let's put this on final. Maybe this is somebody's property. And if I auto annotate that, course, you'll know that those bearings and distances will change, but also things like the area. And if I want the area by a closed polyline, and again, I'm just taking the defaults, and it's going to be, some value there. In fact, let me just move it over here out of the way. So that's 3,610 square feet or 0.0829 acres. All right, now, if I should move this, notice not only the bearings and distances changed, but also the area label. Let me get that up here out of the way so I can make a bigger change here in a minute. See, those things are constantly changing and following around. Okay, now, should that switch be off when these things are created, I can change that in all the world and the labels would not change. Now, what you would do in that case, I'm going to uncheck my labels. And now I'm going to draw another figure here. Let me set that up so you can see that a little better too. There we go. So now if I should auto annotate this guy, let me see my text sizes. Okay, I'm good. And now if I were to edit the figure, notice how they stay. All these things are, if I select them and look in my properties, which I keep docked over here on the left-hand side, and if you don't see it, right-click the mouse and all the way at the bottom, choose properties to get the dialog box up, and then move it over to docket if you want to. But if I look at the properties of that particular label that was part of my annotation that followed automatically down here, but I see in my properties, it's nothing in the world but a standard AutoCAD MText entity, a multi-text entity, multi-line text entity. So I could do, very painstakingly go to the effort of erasing all these old ones and recomputing it, or if in your annotate defaults, you tell it right here for previous labels, you can either keep them, erase them, or prompt to, to let you decide at the time you run it. So right now, if it's just set to erase, and even with that linking off, all I have to do to get the same effect is to just go back and auto annotate that figure once again. So when I had that switch set to erase, it found the old ones, erased them, and recomputed them. Okay. I've got some. Yeah, I thought so. Text size scalar 0.125. Okay, so this time now, area by closed polyline. Oop, I forgot to do the other one, sorry. So, so there that is. But again, because this was drawn with that switch off, even if I turn it back on, which I think I may have not done yet, but yeah, there we go. So now even with that back on, it's not going to update automatically. But all I would do is just redo the command. Now, that one did not erase, it kept the old one. And that is on my area defaults, which I don't have anything set up for those here to erase and redraw. But right here is if I have erased previous. Now, if I go back to area by closed, notice it erased the second one, which was its previous. This one, however, was done without the linking on, so it's not, it's considered basically orphaned. But now if I go back and auto annotate, which will be the bearings and distances, now it works. And you notice how they changed this time. So what we're talking about, the switch being on, in this case, that applies to whether the switch was on, not when you created the line work, but when you created the labels. Okay, whereas above, link line work with points is when you created the line work, if that was on, it sets the link. Okay. So it's a very handy feature. Sometimes, and I usually leave it on to automatically update always. But depending on what you're doing, you might not want it to. You might want to, in particular with surveying and with property plats and things like that, because you might draw a figure based on your deed descriptions and you read out your distances and your bearings and distances, and then let's say you needed to go in there and just sort of tweak around the actual endpoints of the lines, maybe really small, but if you label it once the way you've done it, and then you go in there and tweak around the endpoint a little bit, you don't at that point necessarily want it to update the label that was matching your deed. So that's the reason there's a switch. There's a reason it doesn't always follow, because sometimes, and if you're not aware of that, you move something around and it starts to change those bearings and distances, that's when it gets into lawsuit territory, because you're talking about property ownership. So be aware of whether or not it's going to update, and set those switches accordingly. And then finally, the last one, you give yourself a little fun thing to play with here. Let's go out here to the empty space and let's draw a 2D polyline. And we're going to turn this into an alignment. Okay, so we're going to, let's see, do I have no, I don't have. So I'm going to put this on a layer called center line. I'm going to say, okay. And I'm just going to click and draw the figure like that. Okay. And let's, for yucks, go to our center line layer that just got created. I'll make it cyan colored. I will choose a center to line style, and let's make it big enough for you to see. And so there it is. Now, doesn't look much like a center line of a road. It could be a center line, say, of a sewer alignment. Maybe these are all manholes, and that would be perfectly fine. But let's say we were making a road, making a little access road into our site. Well, I don't necessarily have to, fuss around with trying to make, the curves and everything in there. And I've got several ways I can do those curves. I can just do a standard CAD fillet command to put the command in there, or I can use my, Carlson draw tools and use my centerline tools. But let's say we get just, and these would be just the PIs, the points of intersection. Okay. And let's now go to our centerline menu. And one of the choices is to, you see, you can do an editor, you can do a design centerline, which is where it's going to ask you, we're going to call this one junk. And it says, all right, so give me a layer, give me these. I've got super elevation rates, a starting station. So you do all of the different types of things. You jump right into the design stage, but sometimes it's easier just to draw the darn thing and now turn that into a centerline file. So that's one of our options under centerline. Let's draw a centerline file. Oh, I'm sorry, not draw the file. But go to center line, and we're going to turn this second command down that says turn the polyline into a center line file. So we're going to choose that, and it wants to know the file. I'll also call this one junk. And it says, look at the command line now, and look at the line above it. It says, first of all, select the polyline that represents the center line, but it also tells you above there that it should have been drawn in the direction of increasing stations. And if it's not, it gives you a chance to change it. So I'm going to pick it. And it's going to show me with these little temporary graphics the direction that polyline was done. If my intent, though, is for that alignment to go from right to left instead of left to right, I can choose the option there on the command line, R, to reverse, and it would change its direction. Okay. And you can just type R to reverse again, either way you want it. So then you give it a beginning station. Let's call it 1367.83. Okay. And so off it goes. It makes a bunch of little calculations here, and it shows you LI, that means line intersection. Then press enter to continue. Boom, it's done. Now the file is written. Okay, now here's a couple of other things to keep in mind. I'm going to take this file, that center line, or that polyline file that we had earlier, and I'm going to right click and move, and just move it up here just because we're working with this. Now, if you double click that first polyline we did, it's just a polyline. You go and double click it, nothing seems to happen graphically, but look at the command line. It's running IntelliCAD's p-edit command, the polyline edit command. And this is the standard CAD version of that command. Okay. And that's called its shortcut action. Now, that's a polyline. If I select it, I see that it is up here in the top. It's a polyline. I select the blue one that we drew and turned into a centerline file, and I see it is also just a polyline. Nothing special about it, except because we turned it into a file, double click it, and you get something completely different. You don't get the p-edit command, you get Carlson's centerline file editor. And so here's how the linking works. Now I can go down to any one of these things and change these values. And if I just double click any one, here's my, you know, northing and easting. I can use a different point number. I can give it a specific length, different stationing, et cetera, et cetera. But I can also, to put my curves in here for a roadway, I can sit on, any given one of these segments. I'll sit on this one and I'm going to choose down below to fit a curve. And I'm going to fit that curve. We'll make it say a 25-foot radius. So I hit 25 and hit enter, and then it calculates all of these other values. And it also, is creating, I got a PC, PI, and PT value showing up in this little spreadsheet. And I'll say, okay. And so when I do that, it fits a curve in there for me. Now, let's go to, say, this and double click that tangent. We're going to make it twice as long. And so this time I want to make sure I keep the tangential to previous is good. The length, instead of 33, let's make that 75. So let's say okay. And now look at the picture. Okay. Nothing's happened on screen yet, but I'm still in my editor. And at that point, let's choose save and exit, and then watch the screen. See what it did? It automatically updated, and I'm going to move this up here just to get it off of that figure there. All right, so now, and if I double click that, I go right back to my editor. Now, here's how this linking works too. Because this is just a polyline, I can edit this polyline any way I see fit. One of the commands I can do on that is edit fillet. That means it's going to fit in a curve in between two adjoining segments. So if I choose that command, it says select the first entity, but reading the line above, it tells me my current settings right now are set to trim and my radius is set to 0. So I'm going to type R or choose this radius choice at the command line and give it a radius. Just I'm going to make that a radius of, say, let's say 50 feet. Hit enter. And now it's back to asking the first entity. So I'm going to hit the incoming tangent. I'm going to pick it. I'm going to pick the outgoing tangent. And if I do that, it fits a 50-foot radius curve into this standard polyline. Again, if I go back and either double click this or go to the centerline menu and choose centerline editor, it's going to ask me for the file. I make sure I'm on existing and I see there's the name of my file. I see a little preview of it. I say open, and notice it has now incorporated the changes I made out here graphically in the CAD system. I did not have to fit this curve. There is that curve. If I double click it, I see it has a radius of 50 feet. So if I turn that down to make it 35, for instance, and say, okay, it shortened it up, I can save and exit. There it is. And then one final deal is look under the centerline menu and choose station polyline centerline. Okay, so I've got a command here to create the station labels. So if I do that, and again, just take your defaults, I think, you'll see the effect of it. I'm just going to say, okay. And it's asking me to pick a file. So there's my file. I'll choose open. There it is. I've got my starting station. Remember, it's 1367.83. Comes around and shows my PC, my PT, gives me my radius. Okay, there's my, it goes from 13, 14, there's 15. I don't see, where's my 14? 1367. It should have picked up. There's my 1450. Doesn't quite go to 1550, but if I were to select this, just extend it, and let's do the same thing on this end. Okay, now notice the stationing did not automatically update here after doing this graphic edit. So all I would need to do, however, is just simply double click it and get the file up and just choose save and exit. And it will go back out and recompute and redraw the stationing for us here. So there's 16, there's 15. What happened to 14? One hundred, 50, 50. Ah, it's just even stations. I need evens and odds. And say, okay, there it is. Is that right? There's odd stations, start and end stations. Well, I sure do not. I have any idea why it's skipping 14. Let's see, distance for stations every 100 feet, 100 feet along the curve. Intermediates are every 50 feet was on the curve. That's a distance interval of 2, 3, etc. Odd. Non-interval stations at this. Could have worked. I don't have any idea. Excuse me, why it did not do that. Station 14. I don't even get the tick. All right, let's try this. If I double click, and I'm going to just, instead of changing any of those, I'm going to change the starting station to be 0. Starts at 0, goes to 63 to, yeah, see there it picks up 1, 2. So if I change that station to be 1367.83, see, save, exit. It goes back to that, but never gives me my 14. Let's make that 1550. Yeah, see, that did it. So instead of 67, let's make it 47.52. Yeah, that's working. So what is special about 1367.83? Huh. Let's try
Hey,
1367.
Ken, the only thing I noticed, there is a tick mark, but it's in between your point of curvature and your point of tendency, but it's not labeling it.
Yeah, but that's, see, 1431 to 58, that's 1350. And it's not supposed to label the half station. See, there's another one.
Okay.
So the full station, there's 15, there's 16. There's something it doesn't like about that. And if I use, I think it's just using the decimals. No, that still did it. But if I, oops. If I do 1349.75. As soon as I go over 1350, and you see the little half tick for 1350, as soon as I go over 1350, this, I know why. It didn't have enough at 1367.83. It's not there because 1367 to 14, it's less than 50 feet to where it hits station 14, which is going to be like right in here somewhere. If it has enough distance to get that full cycle in, then it should pick that up. Now there's another option. If I increment from my beginning station, yeah, see, that takes the same interval, 1367, and then becomes 1417.83, and then 1467.83. So that one was not the option that I was looking to do. If I specify start and end. No, right back to where it was. So, well, that's interesting behavior. That's a bug for me to send up to Carlson, because if I start this at, say, 1390, I should come up here 10 feet away and hit 14, and I should see that. But they're not drawing it until they get the entire 50-foot segment in there. Now, all right, so distance, see, there's that, the intermediate stations are going to be 50 feet. So if I were to make that 10 feet, and then let's look at the marker setup, doesn't give me a chance. Label setup doesn't let me. Yeah, see, if I do 10 feet, I get the 1400, but then it puts the 10-foot ticks in there, so I can't suppress that. Hmm. I'm going to say save as, and I'm going to put this in our file here. I'm going to call it centerline station error for tech support. All right, so I'll close that and I'll come back to mine here too. Wow, that's interesting. Now, when I send that bug report up, you're going to see within about a week or less, you're going to see there's been a new version released that you can update your version. So sorry about that, but c'est la vie, c'est la guerre. Interesting. All right, so that's how that linking works, is by whether those switches are on. And you notice when we made all those changes, all those things updated themselves automatically. They were dynamically linked. And that kind of behavior is all throughout the program. For instance, even in your see, like, and you're doing your road designs in let's say, or even in sewer designs as well. If you're if the terrain model that you're using as your existing ground, or even if it's something to do with the final grading, if those terrain models should change, will they change that automatically? Well, yeah, like, and profiles, for instance, if you draw a profile of this center line as it crosses over a terrain model, and then let's say we just wanted to move that road, we could just select it and, pick it up and move it, to some other place over here, but keep the geometry the same. Well, then it would, now, let me just save an X to bring the labels back. So when I do that, if I'm in a different place on this existing terrain model, it's going to automatically update. Now, let's say if I've drawn the profiles over here in the drawing, and then I move this around, it's going to automatically go to that profile, recut the existing ground, and redraw those profiles that I've already drawn, if I have that switch on. And there's a number of places for that. And one big one that we use is in this road network. And again, we'll just give it one called junk. So some of my settings here, then when I'm doing my road networks, is process on updated design files, which means it's going to take all of the interconnections, the intersections, the cul-de-sacs, the grading objects, curb cuts, and everything. And if I make a change, because this is sort of my central clearinghouse where I work on center lines and profiles and cross-sectional templates, road templates. And if I make changes to those, if I tell it to process on updated design files, so as soon as I were to make those changes in those individual files, it's going to automatically add, or make that change. So it would automatically choose if I have it set to auto. If I have it set to off, then it lets me make the changes until I go back and hit the process button again. So you're given the choice in some places. The object linking that we just looked at a minute ago, and with this business, just the standard link labels with line work. You have places where you can check them on and off in those areas too. So, but when you get into processing road networks, particularly if you get a road network that has lots and lots of files in it, like in a subdivision. In fact, we set all this up and we trained. I don't know if either of you've heard of an engineering company called Dewberry. They're huge on the East Coast. They go from like New York City all the way down into Florida. And um, they had a subdivision they were doing in Northern Virginia in the DC suburbs, and they put all this stuff up in RoadNet, and they had 150 some roads in this subdivision. So it's a huge subdivision, but it's all tied together and all interconnected. And if one thing changes, it pulls along all of those interdependencies, where roads cross other roads. If I raise up one road, it's going to pull the other road up with it. So you're not trying to cross the road, 10 feet into the ground. So if they had that surface updating, that automatic update, if it was set to automatic, every time they make a little change to one, it has to recompute that whole thing. So they normally, and in fact, I think they may have been the client that caused that linking to be turned into a choice, whether you wanted to turn it off or to be prompted for it or to have it automatically go. I think it used to automatically go. But so now this time they can turn it off, make all the little edits they're going to make. And then once they're through making those changes that they knew about, then they just go back and reprocess. Much like we did on the label linking, where we just went back and auto annotated so that it recomputed the labels. Okay. Make a certain amount of sense at this point. You got a handle on the settings and the linking behavior and how that
Yeah.
works.
Yeah.
Yep. Yep.
Good to go with that. All right. So let's talk next about some, well, let's go ahead and just leave this in here. We'll talk next about some, really the nitty gritty to everything about Carlson. Um, I'm going to leave these point exercises. If you guys, now, William, do you guys do your own survey work for, I know you have to do those map changes, the permitting and stuff.
We do some, and then we also have a consultant company that does quite a bit as well.
All right, so when they're doing the work for you, do they give you the finished product or do they just basically give you the coordinate file?
They give us the finished product.
Yeah, so that's not something you'd have to worry about with them. But sometimes, like, you'll have a surveyor that'll work on something and they're just giving you points, and then you
Yes.
want to do
Yeah.
the processing. So in that case, that's a good place to be able to use these points, these Carlson points. What I'm driving at here is there's a whole section here starting on page 11 in your manual called points and point groups. And it really explains the nitty gritty of what these are and the fact that they're actually two different things. There's a CAD point, and then there's this Carlson coordinate point, which is the CAD point plus a symbol plus the labels. It's basically that group. Okay. And then there's some exercises, some of which we've already sort of done. We've drawn some lines and, there's that points 1, 2, 3, 4, 5. That's their same points right there out of that file. And then using point groups, if you find yourself doing a lot of drawing based on point descriptions and such, if you break these into groups, they can sort of help you sort of better organize and track those points. Sort of like what they used to do is they would put all those in separate coordinate files and treat them individually, but now we can, call this as a group within our single coordinate file. So anyway, because of that and the fact that that's not normally part of the civil training, I still though will I'm going to leave those exercises here with these points and point groups. I'm going to leave that to your own devices, and we need to jump into our surface modeling concepts and how how Carlson does these surface models, because otherwise we won't have time to even look at road design at all tomorrow if we don't get, a little more headway on this kind of stuff. So all of those things there in the book, I recommend that you, spend a little time and go through them. There, you'll see the step-by-step exercises right here. Open the CAD file, civil demo, do this, do that. Step 2, list the points, little notes and things here. Draw locate points, all the points that match the descriptions, et cetera, et cetera. So, step by step, they're showing you there, and they're showing you some pictures of what things are going to look like. So now, having placed that bookmark, let's talk about terrain modeling and what's going on with this. How do we build surfaces? And there's a little bit more involved in that process other than just running triangulate and contour and letting the computer spit stuff out. Because we need to learn some potential errors, some potential sources of error, and how do we fix those? What do we do about those things? Okay. So this is where that discussion is going to happen, and it sort of is going to take, it's, kind of small here. It talks about here, I'll start on page 18. The first page here really just talks about, what are contours, what is, we as engineers are, really familiar with contours. We can look at a contour map and see immediately, where things go uphill and downhill. We can tell, there's some elevation, some relief to our terrain. But contours are really nothing more than just a snapshot of a surface. The surface itself is continuous. The contours is just a way to draw that continuous surface, and we choose to do it by drawing lines of constant elevation. That's my contour. All right, so I'll leave that to your digestion there. But what we're going to talk about is here the basics. So here's this first page 18, just a little intro of what's going on. Starting on page 19, you've got 1, 2, 3, 4, 5, 6.5 pages of terrain modeling theory. Now, when I was in college and taking this stuff, we had an entire book on terrain modeling. And we took an entire semester to, although in those days, I think we were on quarters, had not yet switched to semesters at Virginia Tech. But in that case, we would take the entire quarter or the entire academic term and study that one concept of building surfaces, what's going on when we build a surface. So I'm giving you, 6 pages, 6.5 pages. So it's a really condensed, boiled down, 35,000 foot view of the process. But it's there. It explains some things as you go along. We'll talk about them. I'm not going to read the stuff to you, and then we'll do some exercises to sort of see why we have to do things the way we do. Now, are either of you folks familiar with the concept of what are called break lines? Do you know what they are and why we need them and when and where we need them? Or is this new? This is what you came to class for, in other words.
It's new to me.
Okay.
Yeah, I mean, it's relatively new to me. I've watched some videos and things, but pretty much it's where you have an abrupt change in elevation, I imagine.
Yeah.
Yeah. And there's a real simple way of learning about that. And there's reasons that we want to have them. And you're going to see that through everything we're going to go through next and with their exercise. But starting here on page 19, let's talk about these 4 points. Because here's the way a lot of people, well, maybe not a lot, but here's the way some surveyors used to do their work. They would go out in the field and survey these points and knowing they're going to use them to build the surface. Well, they would go out there and just blast in, a blue million points to try to get all the points to cluster together and all the triangles to build around all those points. And true, they will, but there's still no guarantee that the triangles are going to form the way you want them to form. So some of these guys would do all this stuff and just, oversaturate the data set with points and then the only thing they would build a surface from is that collection of points. Okay, that's really only half the game. And here's why. So if you consider just these 4 points that you see on the screen now, I've got these 4 points, and this is the way, and all this discussion above hand is talking about how triangulation works and what it's doing, is that it's looking at every point that has elevation, and it's trying to form triangles between that point that the computer is sitting on at any given time. It needs to, the way it forms a triangle is that it connects to 2 other points. Okay, and it has to do that. It has to make that triangle. Now, the reason we use triangles, for instance, is because it takes a minimum of 3 points to define a plane in space, in 3D space, not a level triangular facet necessarily, but any 3 points will define a plane. And then we define our surface as an entire network of these irregularly shaped triangles, hence the term triangulated irregular network, or what we know as a TIN, a TIN. And so it does this by connecting up to all the other points it can see around itself. Now, once it makes that connection, so let's say in this picture example that you're looking at, if you're sitting in the southwest corner, the computer's sitting on that point, and it's looking all around itself, 360 degrees, trying to find other points to connect to. So it might look up and see point number 100 in the northwest. Excuse me, not point number 100, but the point with the elevation of 100 up in the northwest. So it says, aha, I'm going to go from where I am. I see that point. I'm going to connect that with a line, or which would be the edge of a triangle. It does all that in memory. None of this gets drawn, but so it takes that as an edge. He goes, okay, that's good. I found that one. Now I keep looking around myself. Well, the next one it might come to, if it's looking in a clockwise direction, is the point in the northeast corner of 110. And he goes, aha, I can see that point. So I'm going to assume that my ground doesn't change, or that my ground changes linearly between where I'm standing and where I'm considering connecting an edge of a triangle. In that particular case, that doesn't change. It's flat at 110, but so it goes, okay, so I'm going to draw a line up there. And then it keeps looking around, and it sees the point in the southeast corner, and it draws that triangle edge. Okay. So now it goes to the next point. Well, let's say it goes up to the northwest, and it sits on that point, and it repeats the process. It looks around itself all in a big circle, and it looks over and it sees that 110 in the northeast corner, and it goes, aha, I changed from 100 to 110 along this line, so I'm going to connect that as an edge of my triangle. Boom, it does it. It keeps looking around the circle. Now, it cannot see the point in the southeast corner because the line right here was formed when it was sitting down here at 110. It looked around, it saw this one, it drew that one, it saw that one, it drew that one. So now this is an edge that's already been claimed, and it now prevents this point in the northwest from looking across it and seeing this point in the southeast. So it's not going to be able to draw that line. It just sees this line in between. It goes, well, I can't look across that. I can't see anything. It looks around and it keeps looking around itself. It can see this one down here, but there's already been an edge drawn down there from when it happened in the previous point. So it only really got to connect to this one point over here. Now it has other points out here. Oops, crap, what happened here? Yeah. So it has other points out in here that it keeps just connecting up points until all the points get closed off into triangles, and then we stitch all those triangles together and make a surface. Now think about what this is saying that this piece of ground is. It says I've got a little ridge line at elevation 110, and it falls off to the northwest down to 100. And it also falls off to the southeast down to 100, but it's high in the middle, low on the sides. Now, take that same deal, and here we have, just went to the next page, we have those same 4 points, but let's say this time it started over here first, and it looked around, saw this 110, it did that. It looked over here, saw this 100, it did that. And so it repeats the process. And now, instead of this line being formed here first, it forms in this direction first. So now what does the shape of this suggest is that I'm down in a valley floor at elevation 100, and it rises up to the southwest to 110, and also rises up to the northeast to 110. So those are 2 completely different landforms and pretty significantly different. Okay, and so we have no way of being reassured, how the computer is going to start to form these triangles. We don't know where it starts, which point it starts on, the order it looks in. There's no algorithmic rules to that we can predictably know. Now, it does use a predictable algorithm called Delaunay's criteria, which governs how close a point needs to be. And, there's some pretty intense math behind it when it's going to build these things. But we don't have any control over that process. Now, here's a classic example of how that can be a problem. Here's my my urban curb and gutter. And I got my surveyors out there, and they're picking up points along the edge of pavement here. There's point A and point B. They also have some points here along the face of the curb, point C and point D. Same thing at the top of the curb, E and F, and then the back of the curb, G and H. Now, the way some of these surveyors would try to fix all this stuff and make it behave itself is they would come over here at some point and they would get a point on the back, a point in the front, a point in the face, a point on the edge, point up the center line, wherever they're doing it. And they do it all clustered there together. And then they go down a ways and they repeat that process. And their hope is that these points are close enough to each other here that they're not going to pick up any bad triangles coming from the other direction, as long as I can form these edges first. Now, that doesn't necessarily work, because what can happen, and often did, and yet when they were delivering just a contour map, nobody really paid much attention and caught it, but here's what can happen. So those same points, if we don't pre-draw these lines in here, these are called our break lines. This is where our triangulation breaks, where our change of elevation breaks. If we don't create this line that runs through C and D, that's our face of curb. If it doesn't exist, then when I go to model my software or model my surface, point A is able to look up here and find point E. And so it connects that as an edge of a triangle. The assumption being that the elevation changes linearly along that line. So you can see right away that's an invalid edge because it goes up in the air and it really should be coming down here to this face of curb and then up to point E. But there's nothing that keeps that triangle from happening. Now, point A can also see point C and point B. So those edges are actually correct, right? Because they are actually lying along those features. But likewise, that we had a problem with A to E, you could also potentially sitting at point C, you could look up here and see point G and just draw the edge through there. Well, now you, instead of being up in the air, you've just drilled through the face of your curb. Same thing, B to F, edge of pavement up the top of curb, just like A to E. Okay. So what we really need to do in this regard is to draw in ahead of time these edges, this A through A to B, and then of course it extends on each direction, and C to D, E to F, and G to H. And as long as those are drawn first, when I sit on point A, I'm going to look over. I can't see point E because that line is in the way. That face of curb line is blocking my view, so I can't see it. I can look down here and see something else maybe on this line here that I haven't drawn in here yet. Maybe also down another one along the edge of pavement. But I can also recognize point C, so that I'll draw, and that one's correct. I can also do the same for point B. That's correct. I could find points out in here in the lane, in the asphalt, and I could see them, and those would be correct, but I wouldn't be able to look, if I drew this center line in, I wouldn't be able to look across there and see points on this side. Okay. So that's, I can't tell you how many surveyors maps that I would get where they would do stuff like that, maybe getting a point out here on the edge of pavement. There'll be a curb structure, maybe a manhole back on this side or a tree or something. And some of those triangles would go from the pavement all the way completely through the curb as if it weren't there and connect to that other point out, further away. All because they didn't draw in those blocking brake lines, those barriers. See? Okay. Now here's the rule, and this is what makes it easy to remember. Uh, and if you ever, if you recall in your education about brake lines, they always tell you, yeah, those are lines along a break in grade. Well, okay, that's fine. I didn't, I had a hard time sort of understanding what that meant when I was in school because I was thinking about it in terms of, I was 90 degrees out of phase, for instance. So if you consider a stream channel, I'm thinking about it as if I am cross-sectioning the stream. So I'm going from a place on the flat ground, I go up to the top of the bank, and now that's where my elevation breaks. So I go down to the toe slope, and it breaks again and goes across to the other toe slope, or maybe down to the bottom of the channel, whatever. So I keep thinking of that line that I'm walking when I'm creating that as a cross section. I kept thinking of that as a break line, but it really, that's not it. What I'm doing is I'm crossing break lines when I do that. I'm actually, when I hit the top of the bank, the break line that exists there is not the line I'm walking on when I'm going cross section to all these shapes. The line that I'm walking on actually crosses that top of the slope, and that's where the grade breaks. And so I would need to go to every one of my cross sections and then connect up the dots section to section to define that top of grade. So I was always thinking of it 90 degrees out of phase. So then once I started, doing a lot of digital modeling, then I sort of had an aha moment and I said, oh, well, gosh, that's nothing more than, you know, the fact that it's an edge. And if it is an edge, that is what we need to uh, put into our data set, so we can connect up a bunch of surveyed points, or we can just, we just draw the edges. We only have to have survey points because those edges will have points in them as well. But the rule of thumb is right here. And there's that little light bulb, good idea. So if it is an edge on the ground, then you need to also make that an edge in the data, in the drawing that you're going to create your surface from. Okay. So now that can turn into a lot of work sometimes. And sometimes it's more work than is really necessary if we have to evaluate what it is what are we modeling? Are we, and are we building a Cadillac or are we building a Volkswagen? It's not, it wouldn't be a good practice to, let's say, take a week and draw in all of the break lines that we would encounter if I'm trying to model, say, half a county for a flood study, some kind of a rain, hydro kind of modeling. So there's times to let some of that go, but for typical engineering design on single sites or even on larger sites, but things that are going to involve grading, things like that, then I want to make sure that I have defined all of those edges so that my contours are going to generate correctly. But really, I don't care about contours. In fact, at some point, it won't happen in my lifetime, I don't think, but at some point, contours are going to go away. Nobody's going to be using contours anymore. We're all going to be using these digital terrain models, these iTwins. You're going to see that technology pop up. So, let's see where we're going with this. So yeah, so not only, the contours, if I put my break lines in correctly, then those contours are going to get generated correctly. But more importantly, the surface itself gets modeled correctly so that I can then use it. I can be confident in it to run calculations against it, like earthworks, uh, volumetric analysis, stockpile volumes, things like that. Um, and I can even take that surface, put it on a thumb drive, stick it on a bulldozer. And again, I don't see the contours or even need to see the contours, but I need to know about that surface to make sure it was modeled correctly. Again, like I said, contours are going to be with us at least for the duration of, beyond my working life, maybe for many, many years to come. It's been a pretty good representation of a surface, and it's been around for hundreds of years. So, I'm not trying to knock it, but it's not the most accurate way to represent a terrain. Now, it could be that that's all the information we have. Maybe the only thing we have is a contour map of the existing ground, and we'd have to, take those contours and put them on the right elevations and then build a surface from the contours, which is the worst possible thing to build a surface from. And you'll see why when we go through our exercises. So break lines are therefore very important. And again, it can take a lot of effort to put in all the break lines that you're going to need. So that's where we have this concept of called like what's called field to finish, which is in the survey module. It's also in the construction module, part of the takeoff suite. To use this automatic way of reading the descriptions on the points and finding out if those points then need to be connected together as drawn line work. And it's done as a sort of a two-way a two-way say commitment, but it's done as a back and forth, a two-way process where the guys in the field who are collecting the data, they have to make sure that they give it the right description to be able to come back into the office, read the points, and just automatically draw the figures. So they have to decide, here's an EP point. Okay, and I've got an EP and I've got a code called EP that says, okay, put this on layer V dash road dash edge and use a particular line style, maybe a dash line or something. And then when you see the next EP point, you're going to connect to that because it says EP. You have certain other codes that go with it, like start and stop. And you've got PCs and PTs, so it knows that in between those shots, it's actually going around an arc. So, there's a lot of automation that we can really gain some functionality from by using field to finish. But it does require that coordination and discipline in the field. So the guys can't go out one day and call EP and EP and EP, and then the next day they start calling it EOP for edge of pavement, or then the next day calling it PVMT for pavement. Because to make it all work, then you would need to have all of those multiple codes that say the same thing. Plus, an EP point will not, even if you have the codes defined, EPs do not connect to EOPs, or, what was the other thing I called it? Ground, face of ground, or whatever it had to be. So, so using tools like that, like field to finish, to help us create those break lines is really helpful if we can learn to use that a little bit. So now, do either of you, I'm going to guess, William, that for sure you have the survey module?
Yeah, I do.
Yeah, because you got the civil suite. Corey, you've also got it as well with your demo. But if you're considering getting another module to go with civil, I would suggest that you make sure you get survey to go with it as well, just for that one tool called field to finish, because it gives us that much additional functionality. Again, we don't have it available in civil, but it is in survey. Now,
So I guess in my situation, Most of the time I'm getting either a PDF of an existing survey, and they're not usually giving me all the ground points. I'm not making my own surfaces necessarily from the points. And like you said, I guess that's not necessarily the best practice, but
Right. Yeah.
um,
Yeah. Because if all you're getting are contour
bunch of
maps,
contours.
then uh, yeah, and we'll see what we'll see the ramifications of that. And what I would suggest that you do, if you have any control over it, is go back and ask these folks to, because they're all using modeling software. They're all creating these models. I would ask them to send you the model, send it as a land XML file so that you can use it. Now, I've seen a lot of engineers get really defensive about that, and they say, "Well, no, we can't do that because of liability, because you might change it, and then I'd get sued." No, you're not going to get sued because you can document what you handed to me. If I
Right.
change it, then that's on me, because you're going to be able to defend your position, and that's the big bugaboo I have with this is these, nobody wants to share their work. And yet it's one owner that's paying for all of this. And he has to pay people to do crap twice and three times, depending on how many hands it goes through. You think about it. The surveyors go out there and they make a nice existing ground model and they hand it to the engineers, but we're not going to give you the points because, liability, we can't, blah, 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 blah. So here's a contour map. Good luck. Well, then the engineers get it and they've got to try to first of all turn that into a terrain model, and then they do their design on top of that so that here's our finished ground. And so now they're the proud owners of two terrain models. Well, then they give it to the contractor who's going to go out there and they would say, ah, no, I can't give you my surfaces. I can't give you my points because I don't want you changing my stuff. You could, mess me up. Well, so now the poor contractor has to recreate the surface, the existing surface, which is now going to be basically taking it from a second generational remove. And so you talk about places where error can creep into the process, right there it is. And there's been many a lawsuit, unnecessarily so, I might add. There's been many a lawsuit over, not being able to interpret that final deliverable correctly or very well. I've seen contour maps and design maps that, first of all, aren't modeled correctly. Okay, I can tell it. I've been doing this for 40 years. I can tell when that happens and see what I need to fix. But you get these people that they're not very confident about what they're doing algorithmically. And so they won't share the data. They're afraid to be exposed with that. They're afraid somebody's going to find out there's a problem. In fact, I was just involved in a project here in Pittsburgh that's wound up in a lawsuit in a court case, and we were hired to do the expert witness forensic analysis of it. And as it turned out, the original designers gave the contractor a map that was in error by around 4 feet vertically. And the reason that happened is because the engineers, started from a drawing that the client gave them that some architect did so many years ago and had the elevations computed wrong by about 4 feet. We're able to check it because we have newer surveys of the same area, and we compared it and verified those new surveys with our downloadable, uh, digital data that we can get, the digital models and contours and all of that from what we call POSDA here in Pennsylvania, the state GIS data repository. So, we found them out anyway. So they did not protect themselves at all by holding on to their information. And they said, here's the drawings, good luck. we're going to wipe our hands dry of this. And the poor contractor now gets it, and he doesn't know that it's off by 4 feet. And he's trying to make it work and trying and trying and trying, and he can't. He's constantly chasing daylight on this thing and can't make it out. All because we had two breakdowns in information sharing. So that's going to be something I'm going to harp on to all my students in all my classes is, learn how to do it and then learn how to be sure about it and do it correctly. Okay. So anyway, so that's going to bring us back now to a couple of concepts that we'll talk about. So we're going to go ahead now and take our break. We'll break and come back at say 3 o'clock. And then that'll give us an hour and a half to talk about some more of that and to see that in action and what results in it. And then tomorrow we can spend working on some actual design examples and grading and some of the tools that we use. But at that point, we should be well versed in understanding how this is going to work correctly. Okay. So any questions to this point?
Yeah, just one more thing about the existing surfaces. So like I said, I'm in the materials testing side, like CMT,
Uh-huh.
and typically when I see civil drawings, if they get the survey, they say existing conditions, they'll just make a note in there that says, survey provided by or existing ground conditions provided by others. And then I guess that's their way of getting out of liability for in case the existing
Yeah.
ground is wrong based on the contours.
Yeah, they think it is. And in fact, this case I'm in right now, the engineers said, uh, contractor must field verify all elevations, blah, blah, blah. They were basically absolving themselves of any liability whatsoever and putting it all on the contractor. Well, we have a thing in tort law called uh, usual standards of practice. Okay. And it is not, it is way outside of the usual standards of care and practice for a contractor to have to go out there and resurvey the work that he's counting on somebody else having already done correctly. And
Mm.
so, the judge found for the contractor in this case, and the engineers at fault. And even with all of that weasel language, you know, don't think it saves you just because that note is in there. And if you're on the other end of that, if you're the port contractor that thinks you're going to get caught short by language like that, get a good lawyer and go chase them down, because the standard practice, the standard level of care and practice and professional practice is that the contractor is not expected to go out there and do the engineer's work if the engineer did it incorrectly. Okay, it's not incumbent upon him to make that guarantee. So with that being said, just and the easy solution to this is, share this stuff, communicate with the other team members, and know what you're doing and be confident in what you're doing and know how to check what you're doing to make sure it's going to work. That's the simple way of doing it. And these guys get in a hurry, and it usually happens when architects get into the land development business and they don't know what they're doing with it. They might be able to draw a nice set of floor plans, but they may be able to model a terrain snippet inside of SketchUp, but they really don't understand the process. And until enough of them get slapped by, you know, good judges and savvy lawyers that know how to make that presentation, then, it's going to continue to happen. We were supposed to have been a paperless office or paperless society, what, 30 years ago? They kept saying, oh, computers here, we're not going to need paper anymore. Well, we've done nothing other than, quadruple our paper usage, because now we have these super fast tools, and instead of them making things super correct, it just gives us a chance to do things a super number of times over and over and over again. And, so the paper is still being used. Now, Pennsylvania has just started, they've just let their first two contracts, it's an all digital delivery. There is no paper delivery, no drawings, and the designers did not have to step through all the hoops to make the drawings. So the text is this height, and this is that height, and this goes on this layer, and that goes on that layer. Nobody cares because all they got when they, received the data and then handed it over to the contractor, they had a digital model, fully digital, and you took advantage of this iTwin technology that Bentley has come up with, and so they're smart enough and good enough to us to recognize that it's not going to be an overnight thing, and people are going to need some training, and they really stepped up their game and done well to make that happen. So at some point, we're going to do it. We're going to ditch the paper, but for now, it hasn't happened. Um, so we'll need to go and we need to learn how to spot these problems and how to either get back to the providers of it or make the changes ourselves just to improve the modeling. But, I never recommend that if you're changing somebody else's stuff, then you've got to document that, so it gets way beyond which button to push in Carlson, let's say. All right. So now, enough prattling on. Let's get on with their break here. If you guys are, if you had any kind of like tea or coffee for lunch, you might need a break. So it's 5 till. Let's go ahead and take our full 15 minutes. We'll come back at 10 minutes after and we'll finish things out. Okay. Any other questions, by the way? Everybody good? All right. I will stop our share. I'll pause the recording. All right, so let's take a look at, let me see, some quick things to discuss here without reading you all of this kind of stuff. But here's what actually is happening is that when we model, we build these surfaces, we're going to basically sit on every point, whether that is a vertex in a three-dimensional polyline, or whether it's a Carlson point, or whether it's just standard CAD point entity. And we're going to look around ourselves and see if we can start connecting up edges to the other points that it's going to find to start to build the triangles. Now, I say we're going to do that. I mean, the computer's doing that in memory. And we're not going to have to try to step through every point in the file. We need the computer to do that for us. But we need to help the computer out by giving it some barriers that it can't cross if it makes sense for it not to do so. In other words, we need to create those break lines. And anyway, this continues talking a little bit here about the modeling process and different data sources. Here's some key advice. Evaluate, evaluate, evaluate. You have to look at this data and see if it makes sense for what you're doing. Because sometimes, you could get a list of points, every 100 feet that have, elevation to the nearest 10 feet on there. And, that might be good enough to plan, troop movements and artillery range computation during a battlefield. Or, 5-foot contours might be sufficient, if we're doing half an acre worth of a hydrologic drainage study. But when we're doing it to build a specific, structure on a lot, or a roadway or something, we need to be a lot more precise when that happens, when we, to model the data. All right, so one of the ways that we evaluate that data is we have to look at it because we're used to looking at things in plan view as if it's on a drawn sheet of paper. And a lot of times things look just fine when they're like that. But if you were to spin it up in the air in 3D, you may see some things that aren't where they're supposed to be. Here's an example right here. And in fact, this block here on the left, there's a road that goes through the site up here, and there's a bunch of brake lines and a bunch of points. And this is all data from a photogrammetry file. And so there's some good sized relief, and you can see if you trace this line right there and over here as well on this side, that's the top of a road cut. And you see right there near the pavement edge, that gray line, that's the bottom of that road cut. So it's a pretty sheer cut. Come over here and there's another gray line right under that black line, and it climbs up to this top one here too. So if we don't have these bottom lines, the road edges and the center line and those bottoms of the bank, if they're not defined in our drawing, we run the risk of sitting on a point on this high top of bank line and looking across the road to this other point high on the bank line, and we've now filled in that pretty significant valley. Okay, now you can see that in 3D right in here. See, there's that top of bank line that runs all along that. So you see that road cut. So, and on this side, it's spun around. You can't really see the effect of it here, but it climbs the hill right over here as well. So that road is nestled down into that cut. And those roads need to be there, those road edges, to keep it from allowing the triangulation to jump the gap. So when we look at it in plan view, we can't really see anything about it that tells us that. We have to look at it in 3D or find some other way of evaluating, because sometimes you see it, it looks fine in plan view, you spin it up, and if it looks like this, well, everything looks pretty good, but sometimes it will look like this, where they've just drawn in the cartoon version of the roads in the bottom of the stream, and they're not elevated. Okay, now, Corey, you're going to get that a lot more often too with your type of work, where you're going to get just plain paper drawings and you've got to put elevations on everything in the drawing. Okay, so you've got to have some tools to do that with as well. And we have some. We'll go through some examples of that. Okay, and we'll learn how to use these tools. Now, here's another potential problem with some of these triangles, is that when all of this data out here in the corner, in fact, this is the same data that you see here, and that's this upper corner up in there. It's sort of cut in a little kind of square looking corner is knocked out of this data right along these lines here. But because we don't have any kind of a line in between here that keeps these points from looking across and seeing these points, well, it's going to let these long skinny triangles form out here in this part of the world. And we don't know anything about that part of the world. We don't have the data for it. The computer makes the assumption that it changes just at a constant rate along those lines. And those are, by visual inspection, those are invalid triangles. A lot of people do this. A lot of people will model terrain this way. They'll go ahead and model it like that, and then they'll delete those triangles. But we have tools that will take care of that for us automatically. Or if we draw a boundary around the data before we process it and tell it, hey, don't go past this line, then it does so. It keeps that intact within that boundary. Okay, so we're going to use, right here's another thing to take note of. Use your eyes, okay, and use these tools to figure out our best possible way of data. So, that's really the best thing that we can do to evaluate this data, okay? So Carlson has a 3D viewer that is very, very powerful, and it's going to really help you a lot. When I'm working on a project, I'm in and out of that thing 10 times when I'm just just modeling, maybe even it's just existing ground. I look at it, I check it, I double check it, I see problems. I go back and fix the problem, I remodel it, and just in and out, and it's just very, very helpful. So we're going to go through a lot of these things that you're going to see in these pages here, some of these different evaluation tools, looking at the 3D viewer. We've got a quick profile view that we can use to help us find some things. And then we can, understand what's going on with this modeling. Okay, so let's open up one of the files first. And let's see if I'm not sure if this is in your data set or not. I think it will be. Let me think. So let's close that file. And let's go back to our start page and let's open a file now. And let's go to our data set folder. And I want to look for, I'm not sure no, it's not. The one I was going to look for is in the survey class, but I'll tell you what, let's go to, instead of that, let's go to Carlson projects. If you go to Drive C, Carlson projects, these should be the files that are included as sample files when you install the software. And let's see if we have it. I may have to pop a couple of them up here to see if the one I want is in here. Let's see. 1, 2, 3. I think it's called Man Topo. Yes, indeed. It is. So if you look in, let me fix a couple of things here. Yeah, okay. So both of you, let me know. Go to your save this now. And if you have let's go to your file open, or go back to the start page and choose open files, and go out here and look on Drive C, Carlson projects, and just look in that folder and see if you have a file there called Man Topo. And if you do, go ahead and open it, and it should look like this. Do both of you have this file? Just let me know if you found it.
Yeah, I found it.
Yeah, I have it. Mine looks slightly different than yours, but it's
Okay. How does it look different?
just all the point styles. I guess all of it's
Oh,
changed.
that's fine, but it's
Yeah.
basically just this little sort of triangular shape collection.
Yes, that all looks the same, but there's also like I don't know, something down to the bottom right. Looks like it's got the contours drawn into it.
Yeah. Yep. I got that too.
You got contours drawn?
It's like a
There's like a
separate drawing
smaller.
down to the right.
Yeah.
Oh, down over here.
Yeah.
Yeah, you can erase that part or just ignore it. We're only going to work up here in this area. All right, now here's our basic command. It's called triangulate and contour. It's on our surface menu. So let's take a look at that. Well, first of all, let's take a look at what we have in the drawing here. And we're going to does it, if you've got your little view cube over in the upper right corner, everybody got that?
Yeah.
All right, so click on a corner of one of those. Like when you hit top, you're in plan view. Just click on, say, this corner so that you're looking at the corner of it, or let's do the shortcut method. Just position the mouse here, hold the shift key down and keep it held down. Now press and hold the wheel on your mouse and then push it up. All right, and you should see that roll up like that. All right. And then you can use the wheel on your mouse to zoom in, and you can see some of these have, there's points that say 17. There's some that have 18 as a description. So I've got a bunch of 17s and 18s, and look at my elevations are like 8.8, 6.2, 6.62, and over here 17 point something. Okay, so we've sort of verified that we have some points over here. And I think your descriptions, what does these ground shots say? They don't say ground shot, do they? They say just GS or G or something.
I don't have any of the descriptions. I just have the point number, and it looks like maybe an elevation, 14s, around 15s,
You
something like
don't, you
that.
don't see any of these 17s and 18s?
No, I don't see any of that.
All I got is the same thing he's got. Yeah. Point numbers and elevations, I think. Yeah.
All right, if you double click one of those points, do you get this little box that comes up, and look on the general tab and look down here in the description? Do you see a description? There's two description fields. One's for the drawing, one's for the coordinate file. Do you see the descriptions in the coordinate file?
Mine didn't even bring up that window. It brought up a different, I guess it's trying to do like a coordinate file.
It's
Yeah.
at,
Coordinate file to process. Yeah.
it's
Yeah.
asking you for a coordinate file. So if you get that up, you're going to get this, uh, basically that, right?
Yeah.
All right, so look and see if you have one called mantopo.crd.
Yes.
Okay, go ahead and open that. And now double click one of the points and look at the general tab and tell me if you've got a description for either one of these fields.
Yeah, mine's filled in. The drawing description doesn't have anything labeled, and the CRD file says ground shot now.
It says ground shot, and
Yeah.
it says like that.
Yeah,
Ground,
but my drawing description is empty.
that's okay. What about one of these other ones that don't have, this, you got 17 and 18? Well, let's do this. Let's go to the points menu and list your points. And let's just say all and hit OK. Now you should see some points showing up here, and it goes from point number 10 all the way down through point number 356. And you should see descriptions of 17, 18, and then ground/shot.
Yeah.
See those okay?
Yep.
Okay, good. Now let's erase everything in the drawing. So let's go to the edit menu and choose erase, select, and then when it asks you to select entities to delete, just type ALL and hit enter, and then hit enter to finish your selection. So everything's out of the drawing now. We still have it in the points in the CRD file.
Sorry, I missed that.
Okay, go to edit,
Yeah.
erase, select. And it's going to prompt you to select the things you want to delete. Just type ALL, hit enter, and then hit enter again.
Okay.
All right, now go to the points menu and let's look at our point defaults. Let's make sure we've got a symbol, we got this, and we say auto zoom, layer for points. Let's just put that on layer PNTS. Say okay. All right, and now let's go back to the points menu and choose draw locate points. And down at the bottom, just say draw all. And it should look like that then.
Mine came up with ground shot with the description now.
Yeah.
And you got 17s and 18s now, right?
Yes.
Over here
Yes. Yep.
okay, so now this is what often happens. There's a bunch of points. The surveyors go out there and they get these points. They come back and say, well, we've shot a bunch of points in here and then we've got plenty of points. So let's just make a surface out of this. And so they'll go to the surface menu. So go ahead and do that and choose triangulate and contour. So go ahead and do that. And this is the basic tool to generate surfaces. So let's look first on the selection tab. Make sure nothing is checked on here. This allows you to filter out certain things and select other data sources. So make sure there's nothing selected. And then let's go back to the triangulate tab. And let's choose to write a triangulation file. And let's select. And let's call this one EG dash PTS only. So existing ground points only. Okay. We'll say save. So that's going to take our data, build a file, and it's going to save it into a file so we can look at it and draw from it and all that kind of stuff. Let's uncheck this inclusion, exclusion area, and where it says shrink wrap perimeter reduction, leave that to none. And erase previous contour entities, pull that down and choose all contour entities. Now make sure ignore zero elevations is checked on and everything else is checked off. Next, let's look at the contour tab and let's choose to draw the contour. So we check that on. Contour by interval. None of these others are checked below that. And contour smoothing is set to no smoothing. On the right-hand side, we're going to set some layers. And this is where our main contour layer, this is where they're going to go. And I'm going to put that on a layer called V-surf-int. So that V means survey. So it's existing surface int, that's intermittent contours. We're going to use a contour interval of 1. And we're going to draw the index contours. And we're going to likewise put that on a layer called V-surf-idx. Okay. And you should see the index interval should say 5. Everything else is as it should be. Now let's go next to the labels tab and check on that you want to label your contours. And we're going to put that on V-surf-CTRLBL. And label style, I don't care what you use there. It'll create it if you don't have it. So we're going to put in this label layer v-surf-ctr-lbl. And for the index label layer, we'll just put that on the same layer name because we're only going to draw the index contours only. So that's really the second one's the one I need. So down below, we're going to have these check boxes on. And we're going to keep that distance interval. We'll set that to, let's make that 200 feet. And we'll just tab out of that. So everybody's got all of these things set correctly, right? Well, look good at that one. Look good with that one. And don't worry so much about the layer names. That's just what I have in mind, and it's left over from the last time. So it doesn't really matter because you're going to see, what gets drawn and where you'll see them show up. Okay, everybody good to go with that?
I think I'm good to go.
All right. You too, Corey.
Yeah, I'm good.
Okay, go ahead and hit OK. And now follow the prompts. Now it says select entities. Well, always when it's asking you to select entities, this is a good rule of thumb for everything. Always read the line above because sometimes it's asking you to select something that you're not thinking about. So this time it says select the points and break lines to triangulate. Well, right now we only have points. So let's just go up here to the upper left. We'll click the left mouse button, let it up, and we'll drag around until we get everything inside our window. We'll click in the lower right. And if you need to go back and get, more that you missed, just repeat that process. Okay. Now that everything's done, you see it still says select entities. So you're through selecting, go ahead and hit enter to finish the selection set. And when you do that, you're going to see it process and you're going to see some contours drawn like this. Now, there's a little weird looking stuff going on over here, right?
Yeah.
It looks pretty good up here in the middle because that's really all the data we've got. So let's take a look at some of this information. So if we were to, spin this thing up like we did before, we see, the contours formed, where those points are, but it didn't treat the points exactly right. I'm going to go back and hit this top in my view cube over here. So what's the net effect of that? So if I look at my viewer now, so I'm going to go now to the 3D viewer. So I'm going to go to view, 3D view, and I'm going to choose my surface file viewer. Okay, it's a little picture of a little, looks like a little stockpile, but it's representing a surface file. So now we're going to, here's some of our recent files. Here's that EG points only, the one we just made, and we'll say open. Now that's going to pop up a viewer. Now it could look altogether different from what you're seeing on the screen here with mine. You might look at it like this, and maybe it comes in looking like that. Or you can double click the top stripe and that will maximize it on the screen. So it's really helpful to take a look at that. And if you're seeing just empty triangles, over here on the right hand portion, this control panel where I've got 3 tabs, get on the view control tab and click this icon that looks like coloring in those little grid squares, and it should look like that. Now, again, we're looking at it in plan view. So what does this look like in a more like a perspective view? So I'm going to make sure I go over here on the right hand side. I'm going to click that little icon that is the 3-colored cube with a little arrow at the base of it. And now I'm going to move my cursor into the drawing area. And you notice when I'm over the blank spots, it's a Z. And then when I get over, and it's not right exactly on the boundary, but when I get over stuff that has data in it, it switches to an XY. I keep going across, it's Z again. Same thing up and down and back as well. Now here's how to control the view so that you can look at it in any particular direction you want. If you choose that icon that we were talking about here, so it looks like this X and Y, and on the edges it's a Z, make sure on this right-hand panel that this middle axis, the Y axis, make sure that's locked. Okay, so that's going to help us control our view. Now, what you want to think to yourself is when you're looking at this, pretend you're standing out in your driveway and you're looking at your house, and this is your garage door. You want to open up this garage door. And it's one of those garage doors that just lays back. It's all solid. There's no hinges in it. It's just going to roll up into the ceiling a little bit. So what we want to do is we want to put the cursor, while it still says XY, down toward the bottom. Now, if it switches to Z, push it back up to where it's an XY. And press and hold the left mouse button and keep it held down, and just push it straight up. And you can't go left and right because we locked that axis. Well, let's push it up like this. And if you have to go back and get another chunk of it, do so. But you want to get it to where it's pretty oblique, not all the way up. You don't want to go underneath it, but just like this. And now let the mouse button up and go down to the bottom and press it, and you can go left and right and spin it around. So now if I look right in here, and if I get an idea, and I go back over here to this panel on the side, you see what I'm doing? I'm dragging around that little light source so I can cast shadows to different directions and stuff. And I can adjust, the amount of contour and brightness and things like that with these sliders. So if I look at that, I see I've got all kinds of chip chop mess going on over here, okay? Which is probably not the way this ground is supposed to look. I can tell that right away. I can also tell it because I know what the data looks like, okay? So it doesn't look like that. And in fact, it looks like it's a nice flat field, but it's got a drainage ditch around the outside edges of it, okay? So what we're going to do is we're going to put in some break lines. And and I'm sorry, what I just did there, by the way, I was here. I went over here and I clicked this little go out of the window or go out of the door icon. That means to exit the viewer. And it's the same thing if I just choose the big red X up in the upper right corner. I like to use a little door icon so I don't accidentally get out of my drawing. So I'm going to come back out here and I'm going to look at these contours, and I realize there's something wrong with these contours and I need to fix them. Well, if I take a look at what I have in these data, let's get rid of these contour lines and labels that we drew, okay? So if I zoom in here, I see some labels here. There's one over there, 10, 15. There's another one up there. So what I want to do is remember those layers that we told it we wanted to draw the contours on. We want to erase everything that's on those layers. So let's go to the edit menu and choose erase. And let's choose erase by layer. So when we do that, we'll get this little box up and we can either type a bunch of layer names or pick them from a list or select them from the screen. So what we do there, we choose that button. It now says select entities on layers to be deleted. All you need to do is get at least one entity on that layer. So I'm going to come up here to where I can see a label and a red contour and a white contour. And I'm going to click up above the white contour, and I'm going to drag down and to the left. So it only has to be crossing. It doesn't have to include everything. If I go to the right, it has to be totally within. But if I go to the left, all it has to do is cross it. So now when I select that, it has selected my contours and my label. It still asks me to select entities. I'll just hit enter to finish. And right there are all those layers that we used to draw the contours. And I'm going to say okay, and it's going to erase everything on all of those layers. Now, let's analyze what we have here. If we zoom in on the left edge, and you see this little cluster of points, and this is an example of the way some surveyors work. They get a bunch of shots out here, ground shots and ground shots, but then they've got some of these points that have a code called 17, 18, 18, 17. And if you look at the elevations, this is like almost 10. This is just over 8, just over 8. And then up here, it jumps all the way back up to 17. So, and if I look at the next one down the line here is another description 17. So it comes from the ground shot here, it gets to 17, and it drops down here to these 18 points is like 9.5, 9.5, and then back up to 11, and then out to some more ground shots. So it looks to me like 17 means top of bank. So if I were to connect all of these 17s and 17s, and then 18s and 18s with break lines that would create those boundaries so that these points can't look across the valley here and choose this point and make a triangle edge. That's why you saw things like this in the data. That right there's a case where like this ground shot looked all the way across and saw that ground shot and it ignored the valley because we didn't have those break lines drawn in there. Okay. Understand that concept? Okay. So let's get those break lines drawn. And we could go to the effort of drawing these all in manually, et cetera, et cetera. But we're going to do a real quick field to finish. So you guys all have survey, right? So let's go to the settings menu and choose Carlson menu. It's down about 2/3 of the way, and go to the right and choose the survey menu. Now, we're going to use what's
I
called
don't have the survey menu under.
under settings.
Yeah, under Carlson menus, I only have civil, geotech, trench, and CADNet and IntelliCAD.
All right, say again, you've got, say that again.
Civil,
Civil.
geotech, trench, CADNet, and IntelliCAD.
Oh, okay. Well, fiddlesticks. I thought you would have I thought you had, when you got your demo, I thought you had the full demo. You only selected those few things.
Yeah.
Okay, well, that's all right. Just watch what we'll do here.
Okay.
Because we're not really going to learn field to finish. I'm just going to use that to help us draw these lines in. So normally in your case, you would, you could do, this maybe. Let me see if it works. If you go to draw, come down here to polyline, down toward the bottom, and let's choose polyline by nearest found. And when that comes up, we're going to draw, we'll make it a 3D polyline, that'll be fine. And then the max separation to join 1,000 feet's fine too. Let's go with description. Let's put in 17. Oh shoot, that's not going to work.
No worries. You can just, I'll watch.
Yeah, but hang on a second. I may have a solution for you here too. If I go 10 through 52. Let me just jot these down. And then we went 53 to 126. And then we went 127 to 158. All right, let's try this instead. Let's go to draw menu and we'll draw a 3D polyline. And make sure that you have the box where it says prompt for elevation and slope, leave that unchecked. And then uncheck this use current drawing properties. And for layer, let's call that 3D dash BKLN, 3D break line. And let's say okay. And now it says pick a point or a point number. So let's type 10-52, see what that does for us. All right, so there it is. It went from 10 to 52 all the way around it. Looks like it's the inside top of bank. That looks good. Let's choose the option to close. So we've closed back around to that one. Okay. Now let's repeat that command. That was draw 3D polyline. You can right click the mouse and choose right there or even from a list of recent commands. So let's repeat the 3D polyline. Keep everything like you had it, hit OK. And this time we're going to type 127-158, hit enter. And that now goes all the way around there, except it did not get the rest of those. That's fine. Just hit enter to finish. Okay. So we didn't get the top of bank back here. We've only got it around the front and on the insides. That's okay. All right. So next, let's draw the 3D polyline. And again, say okay. And this time we're going to say 53-126. Hit enter. And this, yeah, just hit enter at that point too. Now we did pick up, oh, there's a 17 right there. This is a ground shot. So if I move this out of the way a little bit, you can see that that's 0.17 there. Okay. So 17 to 17, 18 went all the way around. I just want to make sure I'm not crossing anywhere in here. And I don't think, yeah, we're just close. I think we've got a little bit of a crossing going up here. So 95, there's 94 to 95. It actually has a little bit of a crossing right in here. So what we're going to do is we want to get rid of this little segment of this polyline here. And let's see. There to there. And then 17. 18 goes to 18. So this 17. Take a look if I 9. Yeah, I think if we get rid of that segment of 18. All right. So let's go to the edit menu, come down to the bottom where it says Polyline Utilities. Then pull over to the right and choose Remove Polyline and pull to the right of it. And let's remove Polyline Segment. And then now I'm looking right up here in this upper right corner. I want to pick on this line segment that goes between 0.94 and 95. I think it is, no, 90, yeah, 95 down here. So this one here, I want to just click that segment. It's gone. And then I also want to get rid of this segment between 10 and 11. Oops, so I need to repeat that command. So I'm going to right click and choose repeat remove polyline. I'm going to pick that segment. So now they should look like that. So they won't cross and they won't give us any errors. Okay.
Yeah.
All right. So now if we use that information to now go back and build our contours. Now I'm going to go to my layer control, which was view, layer control. I'm going to set that 3D break line color to be magenta so we can keep track of them separately. So they're going to look like that. Now, let's go back to our surface menu. I'm going to switch back to civil now. I don't need survey. I'm going to go back to my surface menu and choose triangulate and contour. Again, the third command down. I'm going to leave everything the same except where it says write the triangulation file. I'm going to choose select and I'm going to give it a new file name. This time I'm going to call it EG-PTS A&D BKLNS. So points and declines. And I'll save that. Now I'm going to hit OK. It says select entities. I read the line above, select the points and break lines to triangulate. And again, I can just type the word all and hit enter, and that'll grab everything. I'm through selecting now. I hit enter one more time and you'll see it process. And now look at the contours. They're completely different and they actually look like they go up and down through those ditch areas, right? And we can see that even in our 3D view here out in the drawing, just looking at the contours. That looks nice. And you can see the top of the bank and the bottom of the bank. They're all well defined. So let's look at the file that we just did with our viewer. So view, 3D view, surface file viewer. This time let's choose EG points and break lines and choose open. And now look at the difference. Now we still have, this is where that line ran out up there. So we had a little bit of, you know, dress up that we could do. Maybe this really came around and there should have been some more points out here maybe. But you can see we've now captured the fact that that had a nice ditch all the way around the edges of it. And this is the backside where we did not get um, the backside top of bank. We just went down to the bottom there until we come back around over here and we pick up the other side there now. So you see how much nicer that looks? And here's a good example of it. If you come into this left edge, here's another way to verify this stuff. We're going to look at a cross section of these two surfaces right across here, about halfway in between these ditch points, but we'll do it across here and we'll compare the two different surfaces. And this is on a profile menu, and it's the very first command called Quick Profile. So if we choose Quick Profile, set it to look at the surface file, and we're now going to need to give it two files here. So I'm going to choose my first button. That's like a set button. I'm going to set my first one to be my EG points and break lines. And my second file, I'm going to use that EG points only and say open. So now I'm looking at those two surfaces. I've got my choice of surface file. I'm going to say OK. And now looking at my prompt, it says pick a starting point, or you could use a center line if you had one defined, or a drawn polyline. So we're just going to pick a point. We're going to pick a point that's sort of halfway between some of these ditch points, like right over in here. I'm going to click a point here. I'm going to drag a point across, perpendicularly across to the top over here, and click a point there. And I'm now finished. I'm going to hit enter one more time to finish that selection, and I'm going to get this little viewer up here. Now, look at the difference. You see both surfaces now, and you can see it in profile, and you see it track as I'm moving, and I can, come up here and zoom in a little tighter so you can see where I am. And in the profile view, you see the white surface. That was my first one. That was the one we did correctly with the break lines, whereas the red one is the one that formed without using break lines. Okay? And you can tell it shows you the slopes and all that kind of stuff and elevations over there along the right-hand edge. All right, so, pretty nice verification of what we've got. Now, you can also, while you're in this viewer, there's this adjust alignment button. If you choose that, 3 points pop up, the end points and the midpoint of that segment. And if you click, now don't try to click on it. Just if you click nearer to the midpoint, let's say, you're going to pick that line up and you're going to be able to move it. You just click it once and let the mouse up and move it around. So in real time, I'm cutting both of those surfaces. So you can see when I get near where those points were defined, you see how the surfaces match. So it matched okay in there, but when I get in between, you see how it's starting to lose that coherence until I get back up near to where these others came back into play, and you're going to see them now start to fit back. So you see how that happened? So the last surface we did was okay here and here, but not here. Okay. And let's just put it down, say right in here, we'll just click so it lays down there. I can hit adjust alignment again, and I can pick it up and go over here and look at it on this side. And now you see I'm looking at it in real time again. And I have to, once I click that down, I have to go back to adjust alignment. I'm going to grab the other endpoint and I'm going to swing over here and just be sort of perpendicular to that ditch, and I'll click it there. And now I hit adjust alignment one more time, and I'm going to click and let the mouse up near the midpoint and drag it around, and you can see again the same phenomenon is happening over there, where I've got the points defined, they agree, but where they're not, they don't. Now, the initial question might come to mind, well, who cares? Well, here's what happens. If I need to compute volumes between these surfaces, what happens if I'm, looking at it in here? Then I've got all this area right in here where my bad surface thinks I'm too low. And I mean, I'm too low by, close to 5 feet in there. Okay, so my volumes are going to be way out of whack. when I start to compute, if I'm doing that to get reports on materials and things like that, I'm going to have some bad information. But again, this is what happens. I'm going to go ahead and hit exit and come out of the viewer. But this is what happens so many times. You get surveyors who go out there, and I'm going to freeze that 3D break line layer. I'm going to do another Carlson command view, freeze layer by pick, and I'm going to pick just one of those purple lines. So now they're out of the way. So what often happens is these surveyors go out there and they'll get this like a little cross section around here, and then they'll get these shots over here, and then they'll get another little cross section, but they don't connect the lines up here. And they think that clustering the points like this is going to work in their favor and it's going to control everything. Well, it does in that local area. But when you go halfway between, this point can see this point before these points formed. Okay. So that's why we had to draw those break lines in there before we built the surface. And that's what made all the difference. Okay. You follow that process, that thought process? Now, to show you another little tool that might be of some use for you, zoom in to where you can see, let me see, let's go up here to, we should have made our labels a little bigger, but anyway, if you see, and it's just the red lines that are going to have labels on them. But let's say you've got a label. Well, I'll tell you what, let's erase by layer one more time. We'll do this differently. Edit, erase, erase by layer. Now, these are all of those layers that we had before. They stay in there. So I'm going to say, okay, all my contours are going to go away. Well, don't panic. We've got the file, right? It saves externally. So again, from the surface menu, once we have the file, we can contour from a tin file. Right there it is. So when we do that, we're going to get basically, we're going to choose the file. We're going to use our good file, e.g. points and break lines only. And this looks very similar to the triangulate and contour command, except there's no selection because we're not going to select anything. It's already there. All of our labeling is done correctly here. It's all set up and ready to go. Let's cancel that for just a minute. I want to change the scale of this drawing. I'm going to go to my settings menu, my drawing setup. And instead of a 20 scale, let's make this, say, a 60 scale drawing. And when we do that, that should change our text height. And we'll say, okay. And now let's go back to surface, contour from tin file. Let's choose our EG points and break lines, hit open. And I think we're good to go with that. We'll say okay. And there they go. And now our labels are a little bit bigger. We can see them better. All right, so let's freeze these points layer. This is on a layer called PNTS. So let's go to our layer control. And let's find that PNTS, which is right down here, and let's freeze it. We'll click right in there. So now we've got the points out of the way, and we've just got our contours showing. Okay. Now, what I want to do is to show you a couple little things that we can do with those labels. And that is, let's say this contour label is in an inconvenient, maybe it's like right on the corner. We want to move it up to somewhere else, or maybe move this one up to here. So if you go back to the surface menu, there is a section called contour labels. And if we go to the right of it, and we can say, move the label along the contour. So we choose that. Let's choose one of those labels. And if you get this pop-up, just choose text. And then as you move it, it's going to reposition it. And it's just going to walk that contour. You see how it's doing there? And if I do this one, and then maybe move it up to here, for instance, you see it takes care of rotating and moving it around. And it also looks like it's chopping the contour line and leaving a gap. Now I'll hit enter to finish the command. But what's really going on, if I select that contour line, it's continuous right through that label, but you don't see it because when we chose triangulate and contour, or our contour from tin file, I'll show you this command again. And I'm going to now uncheck the erase. But when we chose to do that on our contour tab, or labels tab rather, down below we checked on to hide the drawing under the label. So it makes a text and a little thing called a wipeout that's the same color as the background. And we've got the frame turned off. So it hides what's underneath that wipeout. So it puts in order, it puts the wipeout down on top of the contour line and then puts the text on top of the wipeout. And so those two things are grouped together. So that's why when you select one of them, you're actually getting them both. Now you may look up here, one of the options says to break the contour at label. And if you do that, it will physically chop out a gap in the contour line. And then you won't be able to move the contour along you won't be able to move the label along the contour like we just did, because it's broken and it has to stay there. And it'll tell you that if you try to do it. So always, in my usage, I always simply hide the drawing under the labels and I do not break it. Okay, so just something to keep in mind, something that might be, if it's in an inconvenient spot, you can move it around, to fix things up nicer for you. Okay. So what are some of the other things? Now we looked at the quick profile that helped us evaluate things. We looked at the surface viewer, which let us evaluate things. And let's go back and go to our layer control again, view, layer control, and let's turn our points back on. That was our PNTS. We'll turn those back on. And now we have basically everything in the drawing that we had were just the points, but we've also got the contour lines. So let's look at what else the 3D viewer can look at. If you go to the view menu and choose 3D view and choose drawing viewer, not surface file viewer, but drawing viewer. The difference is it's the very same viewer, but it now says select entities. And it says above, select entities for the scene. So we're just going to grab everything here. And now we're through selecting, we hit enter. And up it pops, and you can see the points are represented by those little kind of big looking point lines. And you see the contours there that were generated. And if you spin this thing up, you can see right down those ditch lines are nice and pretty. So everything looks good in terms of what got drawn into the drawing. And that all came from that surface file that we built. Okay. And if you ever need, if you get things all whopper jawed and you want to sort of reset things, come over here on the right and there is these two buttons on the right. There's a zoom plan view or zoom extents. Either one will do the same thing. And when you get a chance, play around with some of these other options, like on the settings tab, there is this bounding box. You can show, a bounding box that shows you the extent of everything you're looking at. That's a really good visual check tool. Let's say you had a bad point with elevation of say 150 instead of 15, then that box would be showing you way up here and you'd see that one point up there. And that's a real good way to check that. You can't really see it from here in plan view. You can't tell where the problem was, but that's another good use of that viewer. Okay, now you can also sort of mix and match these things. If I go back to my 3D view drawing viewer and I select my drawing elements here, make sure I got those points there. Come back to this viewer, and go to settings and turn the box off. But over here on the rightmost tab, it says model. I've got these tools up here where I can add things to this drawing. I can go back out to the drawing and get more things to look at in case I didn't get everything. Or I can open up I've got these layers. There's my contour layers. There's my points. If I double click that so it freezes them, see how it turns those on and off? And let's double click the intermediates. Okay, so you can control things by layer in that case. You can also, with this button, the topmost button, or you can go to the surface category and right click and choose add surfaces. Well, let's add our EG points and break lines as a surface. And it's going to lay in there right underneath what we just looked at. What we're still looking at. We're not in the surface viewer, we're in the 3D, or I'm sorry, we're in the drawing viewer, but it still lets us look at these things so we can compare how they happen to fit. If I go back and add another surface now, I'm going to add that bad one, EG points only. And you can see it pokes through in different places. And if I open up my two surfaces here and double click one, I can turn it off. As long as down here I said, I've got it checked on, it says double click surface to toggle visibility. So if I double click my good surface now, you can see the bad surface and you can see how it doesn't fit what we were expecting to see there. So if I double click my good surface back on and then double click my bad surface off, well, that's a nice, much nicer fit. So these are all ways that we can use this 3D viewer to verify what we're looking at. Now, if you recall, in neither case, I'm going to go ahead and exit my viewer. Neither time when I built those two surfaces, in neither case did I run into an error in the condition. It just said, oh, okay, I built your surface. Here it is, boom, bang, boom, done. Resist the temptation to think because you got a file made without an error that it is error-free, because you can see very clearly when you don't use the break lines what happens with those surfaces. Now, I'm going to show you another illustration using this same situation. Let's go to the view menu now, and let's choose isolate layers. And I want you to pick one of the red contour lines and one of the white contour lines and hit enter. So this is, Corey, like what you were saying, you sometimes will only get a PDF file with some contour lines on it, and that's all you got. All right, so we verified everything. We looked at it in 3D and we saw that, yeah, okay, we've got everything here. If I'm going to look at my 3D viewer, I look at what I've got here and I've just got basically the contours and I look at that and say, yeah, well, okay, they gave me, that all looks good. So I need to make an existing ground surface from what my surveyors gave me. Okay. And if all they gave you is these contour lines, now what's going to happen in here? When I'm sitting on this point right here, I'm going to look down here and see the points along this white line. Those are fine. I'm going to see the points up here along these lines. Those would be fine too. But if I'm sitting here, I look away and see these points, they're fine. But I can also look across and see these points in here. And that's the same elevation. So if it starts to create these triangles inside of here, they're going to be flat. Okay, and that's what we call flat triangles. And you're going to see that happen when you choose to build a surface from contours. If that's your data source, you're going to get all kinds of flat spots in there. Not exactly like what we saw where it jumped the ditch, but this is going to be jumping across the bottoms of those contours where they come up. So let's look at that, see what it looks like. So let's go back to the surface menu and choose triangulate and contour. And now we're going to make sure our right triangulation file is on. And we're going to select, and we're going to call this one EG-CTRS only. So contours only. And come down where it says erase previous contour entities, pull that down and choose off, because we want to keep our contours here to see them. And on the contour tab now, uncheck to draw the contours. We don't want to see them over top of our other ones. We're just going to leave them alone. But it will build the file. Okay. So go ahead and choose. Let's see, we've got our new file is written called contours only. We've turned off this erase previous contour entities, and we've unchecked the draw contours, which also grays out everything on labels. So that's good. We'll say okay. Select entities, read the line above. What do you want to triangulate? Well, this is all I've got. And I'll select everything and hit enter. And off it goes, and it tells you, hey, I wrote the file, no errors, right? And this is where a lot of people get in trouble. They go, oh, it must be fine. Well, let's go back and view that surface. Let's go to view, 3D view, surface file viewer. And this time let's choose EG contours only. And let's look at the difference. You see all these things along the bottom. Now we managed to get the tops okay. But over here on these edges, and you can see it, let me change our little, see that mess in there? Because we've basically gone in there and created these flat triangles. Now we can verify that. I'm going to go to my model tab. And I'm going to choose the second button to add entities. And I'm going to bring these contours in. And now when I look at that superimposed with my triangles, you can see where some of these triangles, like right here, look at that triangle there. See how it jumped across there and made that flat? I go back to my view tab, and I can toggle that on and off. You can see these triangles right in here are all the same elevation. And they shouldn't be. They should be tapering down to meet the next contour line. And so I've got right in here, I've got everything here down to this edge is flat. Let me get a little more contrast on that. shading. So you can see this line right across here. Everything inside of that's all the same elevation. Now, if I exit, well, before I do that, I'll show you the difference in those contours. I'm going to go to the settings tab now because I'm looking at the surface file, not the drawing. I can tell it to display my contours. I'll do them at a contour interval of 1. So now you see how these yellow contours that are in my view are being generated. They match up here okay, but down here in the ditch, you see this yellow line comes across here and jumps across flat and goes back. Doesn't do anything up here, but this one comes up, jumps across flat and goes back. So you see those are quite a bit different and they don't work for what we were trying to do here. Okay. So how do we keep, let's say the only thing we have, I'm going to exit my viewer now. Let's suppose though that this is all I have. What are my choices here? And ideally, I could sit here and draw polylines and connect up all these little nose points and go to the other edge of the ditch and draw those and connect up all of the other top points. But that would take you way too long and you'd never get your work done. So we have a couple of helpful tools in that file. And so let's choose surface, triangulate and contour again. And this time we're going to change for yet another file. We're going to call this one EG dash min space flats. Because we're going to minimize the flats. Okay. And right down here on this first tab, the triangulate tab, you can see down here some different controls. But there's one right here, this little block. You can see there's a little faint gray box drawn around it. It says adjustments for source data of contours, because they recognize even though that's the worst possible source, sometimes it's all we have. So let's turn on minimize flats. We'll say okay. Now we'll go back and we select all our data. It builds our surface, and let's compare that one now. So we go back to view, 3D view, surface file viewer. We'll look at the flats, minimize flats. And now you see, and I still left my draw contours on. Look at that. They really are looking much nicer. And even if I turn my contours off, you can see how I've managed to minimize that. And I still have some mess going on, so it's not perfect, but it's a lot closer than what we had before. And get a little more shading over here, see. And if I go to now grab all of this to throw in there, and I'm going to go back to settings tabs and turn on to display my contours. And now you can see, see how well it honored the contour placement in here. It did not right in here. It got a little too close, so it jumped the gun a little. So there's a couple of spots. Over here's another spot back in there. But for the most part, and here, around the front, there's some missing in there as well. It sort of jumped out across here and back. But for the most part, it really helped us out. So anytime you're using data that the only data you have are the contours, when you go to triangulate and contour, make sure that you come down here and you minimize flat triangles. Now you don't want that on if you're not using contours as your source data. Okay, because you want to, because some of that other data, there might actually be a flat triangle, so you want to make sure you catch it. But that's just a little switch that you can use that will build that into that file. Okay. And how about we take another peek at our quick profile? Let's do it. Our first file will be our points and break lines. Our second file will be the wait a minute, it's the first file. I'm going to be minimized flats, and my second file, I'm going to do contours only. I'll say okay, and I'm just going to draw a line just up that ditch line like that, and be done. So now you can see as I'm tracking in here, you can see the results down here in the profile view. You can see the difference. The white line is the one that said minimize flats. The red line is the one that was contours only. So you can get a sense right in here. You've got what looks like a bunch of stair steps instead of the nice smooth bottom to the ditch. Okay. So you can see how much that helped straighten that out. And of course, if we go back and look at the one with points and break lines, you'd see even places like right in here, that would be gone. It would be nice and smooth because their break line data took care of all that. So here's where this minimized flat breaks down a little bit, but you can see here how it right in here, you can see how it helped to alleviate that problem. Okay. Everybody follow that? Questions on any of this so far?
Nope.
If you picked up anything you didn't know before, that's the important thing.
Yeah, yeah, I did. I'm in the same boat as like not having points in my just getting contours and stuff like that. So I'm gonna have to start getting on him about sending me that stuff.
Yeah, I
Yeah,
typically don't even deal with the surveyors at all. I
Yeah.
get the information from the owner, and they're giving me a PDF, or they may even give me the survey CAD file, but it typically already has all the contours drawn.
Hmm.
well, usually what happens or what you can do in that case is realizing that those contours were generated from a process much like we're doing here. So let's say they've drawn these contours and the contours are correct for their surface, but all they give you is the contours. Well, you can say, well, it would be a lot more accurate for me if you could give me that surface information. They can, and if they're cooperative, they may give it to you. I know an aerial mapping company that I do a lot of work with. Their standard procedure when they deliver their data, they always deliver the drawn break lines that they compile photogrammetrically. So they give you all of the points, all of the break lines, everything they do. They also will produce a contour map just to show you, what it should look like. But then you can disregard their drawn contours and go to their break lines and points and create your own file. Now, if somebody is doing this and you've got a good relationship with them and they're using Carlson, then you could just ask them to give you that .tin file, that surface file that they created. And in that case, just, look at it and verify it and then use it. It should be good. If they're using some other software and they don't have Carlson, everybody has this tool now where you can export this land XML file, and they can choose to export those surface files, that the tin data that made the surface. They can generate a land XML file, and then you would simply go to import and you would use that land XML file, and that would read that data out of that file and bring it into you and let you save it in a Carlson tin file. Okay, so now that's only if you've got, you're on good terms with them and they agree that it would be a lot more accurate and less error prone if you could use the same data that they use to create it with. Okay, so, you know, polish up on your diplomatic skills and make sure that, you can get a good working relationship with whoever is sourcing your data and, get that information brought along digitally. Now, again, sometimes all you're going to get is a flat PDF, and you got to go through and assign the elevations to all of these lines, right? And there's
Yeah,
tools.
that part is a pain because sometimes there are hash lines and I have to join the line and then assign an elevation, and that takes an extreme amount of time. And I didn't know
Yep. Yeah, you
there was
got
a
all those
shortcut for that.
dashed lines from like
Yeah.
existing contours. Now there's tools to help with that as well.
I, the
There's
only one I know is join nearest,
or
and
nearest
like,
is right. Yep.
yeah, it's if they get in tight, like you have to be careful. You can't do too many at one time. But like, it
Yep.
seems I don't know. It seems like there should be a better way. I guess the better way is just to get the surface file.
Yeah. Well, or at least get that dash line as a digital file, and it's the line is defined even in the gaps. A PDF though, it's missing that data in the gaps, and you have to
Yeah.
create it. And join nearest is the way to do that. You just make sure your gap is big enough to span the gap.
Right.
But the problem is when they do get tight, it can jump over to the wrong line. So you got to be
Right.
careful. But yeah, that's the only way to do that. And once you do those and you get them as continuous lines, are you familiar with these tools here where you can go to the 3D data tool and you can assign contour elevations?
Yeah, multiples in series, and then you can
Yeah,
count up and down depending on which
right.
what elevation you start at.
Exactly. Exactly. And that's really what you do and how you do it. So, and then just always, once you do that, check and make sure. Now, there's a way, if you have the construction module, now you do not, but that's what they call the takeoff package.
Hmm.
There's a way, and you'll see the settings. I'm going to go to settings, Carlson configure, and down here in the bottom where it says takeoff and SiteNet settings, over here, and it only works in takeoff. It doesn't work in SiteNet. Now you have SiteNet as part of Civil, so you can approach it using that same workflow where you build existing, you build design, and everything else is other. You do all of that kind of stuff, and it takes care of these subgrade adjustments, topsoil stripping, and replenishment, and all of that. But then in the takeoff part, if you have that, if you turn on these colors, you can make everything that you declare as existing in terms of the layers, they'll turn green. Everything that you call design will turn blue or whatever color you've assigned. Other is sort of a gray, but this one right here is the key. You can assign colors by elevation, meaning that if it has no elevation, it's going to be red. And then once you elevate them, they will change color. Let's say they're all going to be existing, then they're all going to be red until you do that elevation change and they'll turn green. So then you can look at this and see right away that you've got something that still has not gotten an elevation yet. And you would you could um, go and focus on that one particular one, because if it's still red, everything's green except maybe this one, then, oh, I missed that one. Or up in here in this corner, you've got a couple of them that are still red, but the others are all green. Then you know which ones to go and work on, and you see it show up in plan view without having to go into the viewer. But if you don't have that module, the viewer is the best way to do it. And you would just, select all that data and say, I'm going to do something here to show you. If I'm going to copy that, and I'm going to go from here, and I'm going to go, I don't know, let's see, at 500, comma 0. Whoops, not enough. Let's go at 1000, comma 0. There we go. All right, so I've just made a copy of it all here, and I'm going to select all of these and set their elevations down to 0 here. Now I'm going to take those same things. So I'm going to move previous, oops, not previous, but these. I'll move them back from here to at minus 1000, comma 0. All right, so now they're laying right underneath there, and you can see I've got two sets, right? So what you would do then, if you don't have that color trick, if you've elevated all these and you got some that are still at 0, you would just go to your 3D viewer. You look at it like this. Now, when this comes in, it's right up here is this little checkbox that says ignore 0. So if you uncheck that, it's now going to show you those zeros, and you can see them in here. I'm going to give it a vertical exaggeration here so I can see some separation. So then you would see the one or two contours that you still need to elevate, and you'd be able to, mark them, or you could even, say, spin it around and get it to where you can see those. And then you can even go out here to the settings tab and come down here to set your CAD view to the current view. And then when you exit, it's spun up there. It's not, I don't have that vertical exaggeration anymore, but I could see, oh, down there's, I need to fix that one. And so you can very quickly see them now, and you would select that elevation and, get it an elevation so that it then becomes what it needs to be. Like this one is 20. So this one was 0. So if I change that to 20, you're going to watch it jump right up to match up where the other is. Okay. So those are just some of the tricks and techniques that you can use. And I'm going to go back to my top view up here and be back in plan view. But so yeah, that can be a pain, but it's nowhere near as big a pain as it used to be, where we would have to select a polyline. And then we would go over here, we would type the elevation, then do the next one, type the elevation. So you at least got some automation that you can take advantage of. Okay.
Yeah. So one last question, I guess. Before you can start doing like any centerline files, any road processing, all that, you have to have an existing surface. Is that correct?
Well, you can actually, you can do road design without an existing surface. You can't use road net without one,
Okay.
but you can make a dummy surface, and then just tell it when you're doing road net. Uh, let's go to here, road network. And we'll just call a new one called junk.
Hey, I gotta run. I'll see you guys
Okay,
tomorrow, 9
I'll
o'clock.
I'll send out the links here afterwards for tomorrow's session. It'll be a different link. So,
Yep, sounds great. You guys have a great
all right.
night.
Okay,
See you,
you guys
man.
take care. All right, bye-bye. So then, once you're in here in your settings, you have to have an existing surface here, and if you don't, uh, when you go to process it, it will error out, and that's just with RoadNet. However, you can make a dummy surface. Just, make four, make a, just draw a polyline around your data, just, maybe a rectangle even, and give it some non-zero elevation, and then build a surface out of it. And so that gives it something that it can look at. But then what you would want to do is to uncheck right here, tie to existing.
Mm-hmm.
So that would build your road based on your alignment and your profile up and down. It just would not tie out to the existing ground. Okay. So that's the one thing RoadNet will enforce you, it will force you to have that. But the other processing, like process road design, that does not make you have to have it. So here's your different input files. There's an existing surface file. But even if you say none, and then once you hit OK and you go into the processing, it won't tie, but it will still process the road portion of it. So,
Okay. And can you show me
but
one more time where
yeah,
you showed that you can create like a project path or like a drawing folder, and that's where all these like file like your surfaces and your
yeah,
centerline files, they all populate in that same folder.
yeah, because if we look at, let's just look at where we've been working. Here's my civil class,
Yeah.
my data sets. And so if I look at these by name, we've been looking at, what do we call it? Oh no, let's look at it by date modified. There we go. So there's that class sample file drawing. There's
Mm-hmm.
the INI file. There's a junk centerline.
What
And
about
let's,
like all your EG and all that stuff? Like
what's that?
your surfaces and things. Could they save in there as well?
Yeah, but now, like if you're doing it with the tools that you have, you're using, are you using Civil to build your surfaces, or are you using like SiteNet?
I would have been using civil because like under surface, I would
Yeah,
have did triangulate and contour or
okay. Okay,
create
okay. So,
create
so
surface from contours, I guess.
okay, so the EGs and stuff like that, let's look at that. We'll just look at Carlson projects here, look at date modified. Uh, let me sort it this way instead.
'Cause I guess I would like to do the drawing folder because, like I said, I'm just getting started. I don't even have that many projects, and like I said, somebody's just helping me out. And he was saying that like even when you're using like importing images and things, like if they're not in the same folder, it won't even populate into the drawing. So a lot of those files I'll save like on my own hard, like my local disk, I guess.
So if I look at these, I'm trying to see where's the ones that we've just been. Yeah, up here's all these EGs that I did.
Yeah.
Was it Mantopo? No, I didn't save Mantopo yet, so it's not, it's right here. I guess I did earlier. So these are all there, and they're all where my drawing lives. Now, that's the way I work with all of my stuff. In fact, if you look at some of my real projects, let's close this up and look here at my documents, consulting.
That's under settings and Carlson configure. And then is that under general settings?
Yeah, it's, well, I'll show you that in just a second, but just as an example here for my, um, here's a project that I did, and it's all under working,
Yeah.
and it may be under new work. So if I looked at new work here, you see, it gives me all of those files that were in. Now, if I look at it by type, I've got, so there's some centerline files,
Yeah. Coordinate files. And
so I've got multiple drawings. I did everything in that one folder, and you see there's a lot of files in there, but I don't really have to worry about that and keep track of it because, Carlson can do that for me. Now, where you set that is right here, settings, Carlson configure, project and data folders.
okay.
And so you either will go to a project folder, and if you do that, that's where you list these other folders,
Yeah. I don't think I want to do that.
or you say drawing folder, and then everything will go, and it's just by default, that's where it stores. So if I then go to do anything, let's say I wanted to design a center line, it's going to ask me for a file. See where it's pointing me to? It's
Yeah.
where my drawing is. This man topo is right there. So if I go to get this recent drawing of this class sample, for instance, and now if I go to that same center line, design center line, it looks for it, but see the folder it's now pointed me to? Because that's where my drawing lives. And these are all the files that are now in that folder. So see, I don't really have to worry about keeping track of all that stuff. It will show me that, where they are in that dialog.
Yeah. So like you have a working folder, but I think I'm going to individually set one up for each project. That way I can just save everything individually. I guess I'd have to go through the process of making a new save path when I
Well, I
start
mean,
a new
I
one.
have a working folder where I'm doing my work because I have so many other things like contracts and, PDFs and things like that that I keep that are separate from
Yeah.
my actual work. And so that's the only reason I keep those as separate files. And I generally declare a working folder or working files folder, and that's where I do all the work. And then when I generate final deliverables, maybe I'm delivering a set of PDF drawing files. I may have a plot files folder, and I've got some folders in there by date. So when I plot, I'll move those over into those locations so I can, go back and forth to different dates and different things I've worked on.
Yeah. Like I said, this is all totally new to me. Like I deal with civil drawings, but I'm like, I don't know how to do all the drafting. I don't know 100% of all the engineering as far as like sizing pipes, but I have someone that can help me with that. But like I said, he doesn't really necessarily know how to use this program to,
Right.
he's like manually grading. Like he's drawing poly lines and tying them into existing
Yeah.
contour lines. And
Yeah,
I'm like, I don't, there's
he's
got to be a better
drawing.
way.
Yeah, he's drawing his contours. And and see, that's the difference and the difference in the approach. Because, a lot of the old timers will still, they're drawing contours because they know what the contours are supposed to indicate.
Yeah.
But that doesn't build a terrain model. And in today's day and age, we're putting terrain models on thumb drives and loading them on bulldozers. So you can't
Right.
do that by drawing pretty little contours. You have to be able to model it. And so the difference is this, and it's a simple way to think about it. The old school ways, you're designing the contour. A new version of what we're doing is we're going to design by edge. Where all we have to do, if I have I've got let me see if I can find it for you here. It's a real quick little picture that will show you. Let me see. I might be able to find it easier over here. If I look for, let's see, documents consulting. Yeah, here we go. All right, if I look for, yeah, right here. This was from a column I used to write for American Surveyor. So I could design this whole thing. Now what it's going to wind up doing is, I've got a building of a um, particular elevation with a 2.08% cross slope on my sidewalk. So I've got this at one flat elevation, and it was, I don't know what it was, 101 or something. And I came down here, so the sidewalk is a constant 2% grade off of this edge. So that set this edge. And then my parking lot was going to be a 3% drop down this edge, but only a 1% drop down this edge. So this corner down here is the low spot. Okay, so I'm not drawing the contours for that. I'm letting the computer do it. And so if I do it that way and just put it down here, then I get these sort of sharp edge contours because I've only got a point elevation here, a point elevation here, and that's flat, you see 100.5. And then it goes from 99.66 to
Yeah.
90.
It's almost like it makes a valley through there, and it's probably not exactly
Yeah,
how
so it
it
makes a
works.
little fold right there. And what this article was talking about is how some people use contour smoothing to try to fix that. But
Yeah.
this doesn't fix it only changes the appearance of the contours. The surface still has that crease in there because there's only two triangles that formed here.
Right.
So what you have to do is, I just very quickly put 10-foot lines across here. and elevated them based on where they touched on these edges. And then I put individual points down each of those lines every 10 feet. And that took care of, see, this is the first approximation where these triangles went all the way across lines, edge to edge, but it made my contours look jagged. But if you do it with these, then the contours are going to, or the triangles rather, are going to form in here like little bitty 10-foot triangles, and it smooths out. So here's the resulting design. It's really more what I intended to be, a nice little even kind of swale kind of thing down, not a crease. And identified it with all this additional data. Now, it didn't take me long to do that. I just popped the line in, arrayed it 10 feet up, set their elevations based on hitting those edges, and then densified those lines and recomputed the surface. Now here it is. And again, this, I don't have contour smoothing turned on at all. These are the resulting contours. And these were the resulting contours before I did that. Okay, so I physically changed the surface between that and that, whereas contour smoothing artificially made the contours look smooth, but the surface is still doing this, even here. So if I put that
Look
surface,
at it in the 3D viewer.
yeah, and if I put that surface on a dozer, he's going to go out there and build me a nice little crease in my parking lot. So I need to do it this way, and that way, that's why I never use contour smoothing, because I like to look at that to make sure I've modeled it correctly. So just some of the things that you'll get to, and you'll pick that up based on your experience and all that. So it's not one of those overnight kind of things, but it's something that, the more you do it and the more you use your eyes to look at these things, use your mind to try to figure out, why did it do that? Well, then, go in the viewer and turn the color fill off so you can see, oh, I've only got two giant triangles. How can I make more triangles than just those two giant triangles? And you do that with a little switch in the software. When you go to triangulate and contour, which I almost always have on, would be this densify break lines, and I'll give it a space. And so what that does is it puts extra points all along those long lines that only have endpoints defined in the drawing, but it builds those points in memory when it goes to build the triangles, and then it discards those points so it doesn't hog up your drawing. Used to be we had to actually hog up those lines with extra points. And that's what that article was showing. That was again written years ago. And the and so that makes your drawing file bigger if you have all those points in there, but you don't need them. If all you're doing it for is to get this smoother, you can just have it do that, and it just makes it and it makes the surfaces larger, but it makes them smoother, and smooths all that out. So, and if you ever did need, we still have right here to densify the polyline vertices. Now, when you do that, it actually physically adds the vertices into the polyline. So right now, if you look at this polyline up here, it's got 1, 2, 3, 4 vertices. And right there's vertex 1, 2, 3, 4, and then back to 1. Now, if I were to do this in terms of a triangulate contour, I would get a triangle edge from here all the way up to here, and then it would go out here and find some other point, maybe over to here. So it'd be this one big giant triangle. Now that triangle might be valid, but a lot of times you'll get, like you saw in those pictures. But if you use that switch in memory, it's going to do this. And we'll choose this guy. And let's go every 5 feet. And so now when I select it, you see all those additional
Yeah, it added them every 5 feet along the length.
So they're all collinear, so I don't need to worry about them. but it actually put them all on there. And then you've got and then when you save the drawing, all of those points get saved in it, so it's bigger file. But you can also then reduce the polyline vertices, and it will minimize it back down. So now I've got 1, 2, 3, 4 again. Okay. You can't do all that densify and then reduce back and forth and back and forth. That's why Carlson put it in the switch now under triangulate and contour. It's now down here as a selectable option. Okay. And I do that almost all the time. Just depends on, what I'm using the surface for.
Yeah.
All right.
Yep.
Give you some food for thought.
Yeah. I mean, I'm looking at all these like subdivisions. I'm going to want to do subdivisions, I guess, because that's who most of my clients seem to be. But I'm like, a lot of other engineers are doing this, and like, I don't feel like I've been utilizing my stamp like to my full capabilities, and I'm kind of getting tired of working and doing this and working for someone else. I'm like, I kind of want to learn something on my own, and I want to do it while I'm still young enough. I mean, I got a family, 3 children at home, so I'm like, if I'm going to totally switch and do this, like I'm just starting it on the side, but it's turning out to be a lot more involved and in depth than I thought it was going to be.
Well,
But
and it would be, and it's good to align yourself with somebody that can show you some of those things. And, so that's not a bad move, actually.
yeah,
Uh, so, and don't think of it in terms of while I'm young enough and can still do it. I mean, I'm looking at retirement. I'm almost 64 years old, and and I've been doing this for 40 some years. Um, just because I fell in love with the process. I managed to get into it early, and I was there during the dark days when you had to do a whole lot of this stuff manually, and it was tough to do.
yeah,
So, but I use it, and I use a number of products. I use this and all of the Bentley tools and all the AutoCAD tools, the Autodesk software, those different things. And the whole process is the same in all of those different programs. You just gotta know you're gonna model things with edges. So what do? Find out where those tools are in that particular package, and you know, you'll be able to go from there. So now this one, I will tell you that Carlson is my go-to when I have to do something really fast. I don't have so much setup that I have to worry about doing like I do in the other products. So it's uh it's a fantastic tool, and it's really fantastic in terms of cost because I could do what I need to do with just the civil module. Even I would even go um, without field to finish the survey if I didn't need to use that. And if I could just whip in my own brake lines, just doing it the way we did it. We draw them, we check it, we see, and untangle the crossings, and a little bit of extra work. Sometimes field to finish can fix it for you, but um, and even at that, it's not all that much additional money to have survey and civil. Um, it's not a bad.
yeah. I saw they had a select suite where you can pick however many different
Right.
ones that you want, and then like you said, it's a one-time fee and an annual maintenance, which is way better than paying $3,000 a year for Civil 3D. Plus, it'd be learning a whole nother program.
Yep, exactly right. So,
So as long as I can create a quality design that can be used in the field, like that's all I'm actually worried about. I don't necessarily need because as of right now, I just want to work for myself. I'm not necessarily wanting to like hire people and do all that. Not yet. Eventually, I guess maybe, but
well, like I showed, the class earlier, that set of drawings that I had, you saw the title sheets, and that was a full set of construction documents, and it got bid on and built, and the contractors don't know any different from that file from anything else. Uh,
right.
they don't really know or care what I'm doing it for. Now, I can't really do a lot of work with PennDOT unless I'm using Bentley software because they actually require that deliverable. Um, and I do happen to have all those, but I do teach this, and this is really my first love. It's probably going to be my retirement gig, is I'm going to just quit doing my consulting and just do teaching part time, and sit on the porch and smoke cigars the rest of the time. So, uh, but anyway, that should be, sort of building the foundation and getting you headed where we're going. But we'll,
Yeah, like when I was in university, I was originally picked civil engineering because I wanted to do design work for like structures and like bridges, buildings and bridges and things like that. And I actually got a job out of college working for like a geotech firm that has a material testing side.
right.
And as I got to doing this, I was like, I've been doing it for 10 years now, and I'm like, I kind of enjoy being outside in the field and like being with contractors and doing fielded work and things like that. And I was like, well, I actually kind of am enjoying this, but as we got sold out to like a big corporation, it's like now a nationwide thing, and like it was like a whole nother situation. But I just kind of got tired of the environment, I guess. And I'm like, I really always wanted to do some design work, and I feel like this is a blend of, you know, drafting and field, and I can be out in the field and at least then I'm getting you do an actual like some design work versus
Yep.
doing reinforcing steel inspections.
Oh, yeah. Yeah, I know what you.
So
Now,
it's
where,
kind of where I'm at.
where did you go to school? Were you in
I
Tennessee?
graduated from Tennessee. I actually went to UT Chattanooga for a year, and then I'm from Knoxville, so I just transferred back home. I was spending money that I didn't have, and I was
Yeah,
like, I'm not
I
gonna
had
do
a
it.
I had a good friend I went to high school with that graduated from UT. He trying to think what he went. I think he's a lawyer now. I haven't kept up with him, but um, now I don't know where Cleveland is. I know where Knoxville is. What part of the state is Cleveland? East or
It's
west?
south of Knoxville. It's down near the Chattanooga area, like on the Georgia
Oh,
border.
okay.
It's
Yeah,
just north of Chattanooga, about 30 minutes.
yeah. So if you go up to the northeast part, up around Johnson City, Kingsport, Bristol, in that area.
Yeah, I have a friend that went to ECSU.
Yeah, so uh now where I grew up is about an hour and 15 minutes north of there. There's a little part of Virginia that has a little bump up that tucks up under West Virginia a little bit.
Hmm.
And that's the county that I grew up in. So it's all down there near Tennessee, Kentucky, West Virginia, North Carolina, all that comes together. And in fact, I used to go down, I studied piano all the way through my school years, and we had our piano festivals down at Virginia Intermont. Is that
Hmm.
called Intermont? I think Virginia Intermont College in Bristol.
I'm not
Yeah.
sure.
Or whatever that college was. But anyway, and when I was a kid, the mall at Bristol was the only shopping mall we had around. And we had to, if we wanted to go to the mall, it was a big event. And then finally they built one up in Bluefield, the Mercer Mall. And then of course they're all over the place. And now nobody goes to malls anymore.
Yeah, they're shutting them all down.
Yeah. So anyway, well, that's good. That'll give you something to work with. And again, we'll keep this discussion. It's going to be on the recording still, because I think it's good information and even be something that William might can take away from it as well. It's more, it's less doing in terms of little rote exercises and more philosophy, I guess, if you will. But it's good to know those thought processes and how we use those to analyze what we're doing. All right.
Yep. Well, I appreciate your time. I'll see you
All right.
tomorrow.
Well, you have a good evening. Don't try to cram anything in tonight. Just go and relax and let your brain relax a little bit and pick it up again in the morning. All right.
All right. I appreciate you.
You bet.
All right.
Take
See
care,
ya.
and I'll stop there recording and